All right. So today is going to be our last meeting for the semester. Possibly our last meeting for this particular course. I think after this, we don't have any other block before your graduation, right?
Yes, sir.
So this particular course today will be our last meeting. Then possibly tomorrow, God willing, we will finish up with the preservation. As I indicated last week, today we will do a bit of calculations. So I think I asked you guys to be with your calculator and also a book of a sheet of paper so that you can practice some of the calculation we're doing online. It's not easy teaching a calculation subject or calculated items online, but I will try my possible best to make it easy as possible so that you'll be able to comprehend whatever that we are going to do today or this morning. So that is what we are going to do, only unit 6. And after that, if you have any question, you can put it on the platform that we find ourselves in. And I'm less busy, I will just respond to it. All right. I don't know whether you've been able to go through the slides for last week. I think last week, the thing that we did was somehow new to most of you. So the understanding, that is what I noticed, that the understanding was not all that good. So I don't know if you have read something that you wish I'll throw more light on before I proceed to whatever we want to do this morning. Are we okay with that? And if there is none to, then possibly I can go ahead. Any other issue that you would like us to address before today's class? All right. So silent means consent. It means that there's no issue. So let's quickly start with today's lesson. Today we are going to look at the energy contribution of nutrients in our diet. So if you remember, I'll be talking about energy, and I told you that when it comes to energy, there are 3 main nutrients that contribute to energy in our diet, and these are the macronutrients. Remember the last 2 weeks when I was teaching macronutrient, I stress on it how they are able to contribute to energy in our diet. So that is what we are going to look at it today. Then we will do a bit of calculation for us to understand which of the macronutrients contribute much of energy to our diet and which of them contribute least. And at what point in time can we also calculate the percentages of these nutrients contribution of energy to our diet. So we'll look at all those components this morning. So by adjectives, we should be able to calculate the energy content of meal. So when a meal is given to you, then I say that this particular meal contains 2,200 kilocalories. So if it contains 2,000 kilocalories, what is the contribution of fats? What is the contribution of proteins? And what is the contribution of carbohydrate to this particular food? So by the end of the lesson, you'll be able to do that. And also estimate the percentage of contribution of nutrient to the diet. So you'll be able to do that. You will estimate each percentage. You will give the percentage range of every nutrient contribution to the energy of that particular diet. Then we are going to estimate the energy requirements from nutrient for individuals. So it is our duty, as we are going to be homemakers, as people will be consulting us for issues related to nutrients. So you should be able to individually estimate people's requirements. That if your body weight is this, if your age is this, if your gender is this, if this is your physical activity, then possibly you should be able to consume about 2,000 kilocalories a day, and that will be something that is okay to maintain your health and that of your weight. So we will look at that. Then we will explain why nutrient energy requirement for individual may differ. We will look at the reason why my energy requirements may differ from yours. It is mainly based on several factors that we will take our time to look at it. If there is time, we will talk about our BMI. We will check if we can be able to calculate our BMI, and we will explain each values that we get, that when your BMI is below 18, what does it mean? If your BMI is around 20 to 25, what does it mean? From 25 to 30, what does it mean? And above 30, they all have interpretation, and we need to understand it properly in order to basically advise people on the kind of choices to make when they are choosing food to eat. And I know BMI, those of you that you've done you remember your nutrition and health and stuff, probably you've meal management, and I think you've done most of these things. So when I get there, most of you will talk, then you will appreciate whatever that you learn during that period. So those will be our objectives. This will be our objective for the day. Then I will take my time to also interpret some few food labels for us this morning. We will look at that. That's when you check your food label and you see 20% of this, 10% of the, what does it mean? So we will take our time to look at that. Okay, so let's move on. So before I move on, I remember even the last week or last 2 weeks, I asked you people about issue of total contribution of various nutrients, especially the macronutrient to our diet. Don't know, I want to tease your brain and see if you still remember them. You remember the contribution of various macronutrients to our diet. So let's say you have carbohydrates, you have fats, now let's say you have protein, then you have fats, and we measure them in grams. So let's say 1 gram of carbohydrates, 1 gram of protein, and also basically 1 gram of fat. These are what I made mention last week. I don't know. I want to tease your brain and see if you remember them. What will be the calorie of 1 gram of carbohydrates, 1 gram of protein, and that of 1 gram of fat? Any idea? Anyone who remember what we said the last time? Yes.
Mr. Bayo, the question again, please.
Hello.
Oh, Mr. Bayo, please, can you repeat the question again?
Yes, hey guy. I can see your hand up.
Yes, please. Good morning, sir.
Good morning.
1 gram of carbohydrate is 4.
1 gram of carbohydrate
is 4 calories. And then fat is 9.
Mm-hmm.
Protein is also 4.
All right. Okay. So basically, this is how the calculation is being done. This is how the calculation is being done. So anytime you have a gram of carbohydrate, it give you 4 calories. A gram of protein give you 4 calories, and a gram of fat will give you 9 calories. So it is basically telling you that anytime you are consuming food that contain a lot of fat, the fat will give you more energy as compared to any food that contains proteins and that of carbohydrates. It is even more than twice, because twice of carbohydrates or 2 grams of carbohydrates will give you 8 calories, but a gram of fat will give you 9 calories. And this is how the calculations are being done. And you see, these are one of the reasons why we always advise you that when you are taking in your food, you should be mindful of the amount of fat content that you take. Well, a lot of fat generates a lot of energy to our body as compared to the other macronutrients. So you need to be mindful of. And I even aside that, breaking down fat to yield energy is very difficult for the body. So sometimes consuming a lot of fat may not be in an ideal situation when you want to prioritize your health. So that is what we need to know. We say that to calculate your energy content of a given food, multiply the number of grams of carbohydrate, fat, protein, and fat by 4, 4, and 9 respectively. Then you add the resultant figures. So after multiplying everything, then you add the results that you get. Then that will give you the energy content of that particular meal. Please, are you following? So let's say a food that contains 1 gram of carbohydrates, 1 gram of protein, 1 gram of fat. What will be the total energy? Do the calculation. A food that contains 1 gram of carbohydrates, 1 gram of protein, and 1 gram of fat. What will be the total energy of that particular food? Yes. If a meal contains 1 gram of protein, 1 gram of fat, and 1 gram of carbohydrate, what will be the total energy content of that particular food?
Sir, please, 17.
17. That is good. Yes, you will get 17 calories.
Sir, please, how do we get the 17?
Wow.
Hello, sir.
Yes.
When you say we
Yes.
have to, hello, sir.
Yes, I'm listening.
Please, when you say we have to multiply them respectively, so I was thinking we'll multiply 4 by 4 by 9.
Hey, I will try. Take your time. We are just starting.
Let me come in.
Come
You
in.
said that,
Mhm.
you said that a gram is 1. So when you multiply, the protein is 1, the protein is 4, the carbohydrate is 4, then the fat is 9. So you just add it up. Thank you.
No.
Oh, okay.
Georgia, I don't know whether you can hear me because see, I heard the beginning of your submission, but the rest was not. Yes, Anita.
Sir, you said what? Sir, you said
Sir,
what?
Yeah, I'm coming. What?
Sir,
Is it Georgia?
yes,
Yes.
sir. Yes,
Come
sir.
again
Yes,
with
you
your
said what?
submission. Come again
I
with your
said that
submission.
I should come in because you said a gram. A gram means you are just adding up. It's not whereby you know the gram that the protein is for, the carbohydrate is for, and the fat is 9. Then you just add up because
hello.
it not asks you to maybe 2 grams, but it is a gram. A gram means the exact. Thank you.
Okay. Yeah. Anita, come in.
So I was thinking that the proper mathematics should be you multiply 1 by 4, 1 by at the other 4, that's the protein, then 1 by the 9. Then after that, maybe you get the same 4, 4, 9. Then you add up. Because if the gram is given that maybe a gram of protein is 2, that one you multiply. So if you just add up, at that point you may be confused. That's what I think. Thank you.
Yes. Okay, so Ashley, can you tell us how you were able to get your figure? Ashley,
Hello, sir.
tell us how you were able to arrive at the figure you gave me.
Sir, you said you multiply the number of grams by the energy, whatnot. So let's say this one you said the gram, it's only 1 gram. So when you take carbohydrates, you multiply the number of grams, that is the one you gave, times 4. And then you put the number aside. you take protein. You also gave protein to be 1 gram. So you multiply 1 gram by 4, by 4. You put that one to aside. And then you said fat 2 is 1. So you multiply 1 by 9. Then the answers that you get, that is 4 times 1, the answer, the 4 times 1, the answer, the 4 times 9, the answer that you had. You then add the answers, not the grams that you gave. You add the answers that you have gotten, the products that you had, you put them together, and that will give you the answer.
All right. Is anyone having different perspective aside what she has said now? Deborah, have you now understand how we are able to
Yes,
arrive
sir. Yes, sir.
at the
Please. Thank
17?
you.
You are welcome. So basically, what we are saying is, anytime the gram of that particular nutrient is given to you, you look at its corresponding value in calories, then you multiply by it. So if it is 1, you multiply it by 4 in case of protein. If it is 1 in case of carbohydrate, you multiply it by 4. It is 1 in case of fat, you multiply it by 9. Then after that, the point says that you add the resultant figures. So after doing the multiplication, if you want to get the total energy content of the diet, then you add all the resultant figure. And the resultant figures are those that you have gotten from after multiplying the grams by the value that has been assigned to each of the nutrients. Please, can I proceed? Do you all agree that you will get 17? Do you all agree?
Yes, sir. Please proceed.
All right, good. That is good. Yes, Anita, I can see your hand up.
Yeah, so when you get the 17, will you write the 17 alone or you write kilocalories to it?
It's kilocalories, yes.
Thank you.
17 kilocalories, yes. If you write it without the units, you are wrong. If you write 17, is it 17 watts? Newton, 17 ampere, 17 watts. So always remember to come out with the values that with the units that is needed at this particular point. So let's look at the sample question over here. There's a sample question in this. I think I sent you this slides last week. So for now, I think everybody is having it. So let's look at this. Let's look at this sample question. The question says, calculate the content of a slice of bread. A slice of bread and a teaspoon of peanut butter, which has been spread. Peanut butter is just a granite paste. If the carbohydrate content is 16 grams, the protein is 7 grams, and the fat is 1. So we need to do the calculation. So let's do it and let's see. Convert each of these nutrients into its calories form or kilocalories form. So do it and let me see. I hope you have your calculators with you. Anita.
Hello, sir. Hello, sir.
Yes, I can hear you. You can talk.
So should we do it one by one or we add all of them?
Do it one after the other.
Okay, so the
look
first
at
will be 81 kilocalories.
the fat will be what?
81 kilocalories. So and hello, Mr. Baba.
I'm listening. You can go ahead.
And the carbohydrate too will be 64 kilocalories.
Okay.
I think someone wants to talk.
All right.
Or I should do the rest.
No, Francisca.
So, and the protein will be
So
that's
please,
seven
then the protein
7 times 4.
be
That's
28.
28.
Please. If I have not called you, it's better you mute yourself so that you can listen to your colleagues. Francisca, come again.
So the protein, as we said, a gram we will multiply it by 4. So that's 7 times 4, which will give us 28.
All right. Now let's do the total caloric intake of the food. The total. Please, I hope you all arrive at the same answer.
He
Is
said,
anyone
please,
having
I'm
Yeah.
not getting it to
The total.
I'm coming. Let me take your time. I'm coming. Someone says she's not getting it. Who is that?
He said, please, it's Deborah.
Deborah, where are you finding the difficulty?
Sir, please, how she calculated each of the protein and the carbohydrates and fat.
Deborah, listen, let's look at our first slice. The first slide that I spoke about. What we said is, and I hope you understand the first one, how we were able to get the 17. Do you understand that?
Yes, sir.
How did you get it? How did you get the 17? Can you explain that one to me?
Sir, please, she calculated the gram weight, the quantity that was given. So it was 4. So 4 by 1, 9 by 1, then 4 by 1.
Okay.
Then
So
she added all together.
Okay, so let's use the same thing that you have said to deal with the question that has been given. The question says you want to calculate the energy value or energy content of a slice of bread. You have a bread, it's just the slide, and you have spread the slide with some peanut butter. So basically, that is your granite paste. You have just spread it around it. That is the food you want to eat. And it can assume that this food contains 16 grams of carbohydrates, then 7 grams of protein, then 9 grams of fat. Deborah, are you here with me?
Yes, sir.
So if you want to get the energy value of the carbohydrate, what will you do? Knowing that the kilocalories of 1 gram of carbohydrate is 4. So what will you do to get the 16 grams of carbohydrate?
Sir, please multiply the 16 by 4. Or
You multiply the 16 by 4. Very good. What about the protein?
7 by 4.
7 by 4. What of the fat?
Sir, please, 9 by 9.
9 by 9. And have you done the calculation? Have you done those things that you are telling me?
No, sir.
So you see, if you don't do it and we are moving, it will be very difficult. I hope you have your calculator with you, not your phone calculator. I ask you people to be with your calculator. Well, I know some of you are using your phone to log in. So if you are using the same thing to do the calculation, probably you may not follow. Then when you
Mr. Bauer, the magician.
Yes, when you do the calculations like that, and you have your figures, you get to know that the figures or the formula or the approach that you have used is the same thing that your colleagues also used, and they gave us the answer. I mean, when I have also done the calculations, but I compare mine to, I use the process and compare it to what you just said, and they are the same. So the only thing that you have not done is you've not done the actual calculation to arrive at your answer. But I think you understand the process for now.
Yes, please, I do. Thank you very much.
Please, can I proceed? Is anyone also having any difficulty?
Yes.
When she was talking, I saw some hand up, but I just wanted to address the issue before. I want all of us to be at the same page. And today we are doing calculations, so I'm going to have patience like I'm teaching, I don't know whether nursery or KG2 student. If you even throw your bag away, I'll go and bring it. And you all be at the same page so that we understand. Because if you don't get it here, I don't know how you are going to do it to understand. Okay, so what will be so we are saying that the proteins the protein, the gram that they gave us was 7. So you multiply your 7 by 4, which will get your 28 kilocalories. Then you multiply your carbohydrates, which was given to you like 16 grams. The carbohydrate was given to you as 16 grams. And you all know that a gram of carbohydrate is 4. So you multiply the 16 by 4, which will get your 64 kilocalories. Then you multiply your fat. It was given to you as 9. So you multiply your 9, and a gram of fat is also 9. So you multiply 9 by 9, which you get 81. Then when you are done, you add everything together. If you want to know that. So let me go step by step. You add everything together. So now you add 28, you add 64, then you add 81. So what will be the total calorie of that particular food? The total calorie of a slice of bread. And I'm seeing the same hands. I want to hear different people talking. These hands I'm seeing are those who have been talking always and always. Okay, let me go to Rejoice.
Sir, please, it's 173 kilocalories. 173
kilocalories.
Yes, please.
Yes, patient. Did you also get different answer? Yes, patient.
No, please. It's 173 kilocalories.
173. Any other person? Francisca?
Sir, choose the same 173 kilocalories.
So, me,
Is anyone having
sir,
different
please,
answer?
173. So all of us got the same answer.
173. You all got the same answer. Okay. And it's good. I'm happy. If all of us are having the same answer, then possibly I think we are on track. So let's even look at the sub question. The question says 1 gram of each of the nutrients will give you blah blah blah. We've done that. Then 1 gram of fat will give you 9 kilocalories. You all know this. Then the question also says that you calculate these are just the formulas. To calculate the energy content of the meal above, the quantity of nutrients have to be multiplied by their respective factors, which was 4, 4, and 9. That is the factors. To determine the percentage of calories supplied by any of the nutrient of the meal. Okay, now there's another question. The last question says that we should determine the percentage of calories supplied by the nutrients. So I'm going to go a step further. Now we have been able to learn how we are going to calculate the individual calories. Then also, we've been able to find the total calories of the content or the food content. Now we want to do a step further. We want to know what percentage is carbohydrate contributing to the food? What percentage is fat contributing to the food? What percentage of protein contributing to the food? And this is how we do it. We all know this basic arithmetic in JHS. If I want to get the total percentage, or if I want to find a percentage of, let me use fats. No, let me go in for protein rather. If I want to get the total percentage of protein contributing to the total energy, what I will do is, what is the value for the protein in calories? What did we get? What did we get?
28.
28. So we are going to divide 28 by the total calories or the total energy that was given. The total energy that was given. Then after that, because we are looking for percentage, we multiply it by 100. I want to repeat it again. What I'm saying is, we are going to pick the value of the proteins. We divide it by 173, then we multiply it by 100. I think Tilly just did that particular formula, and you can see it at the comment section. So let's all do it. 28 divided by 173 times 100. So do your calculation. Do your calculation and let's see. Do your calculations and let's see. Who has
Mr. Moa,
finished?
please, I don't understand what you're saying.
You didn't understand.
Yes, ma'am.
Okay.
Yes, sir.
I hope you are online or today your network is no good. The only Accra guy who is having problem with the network. Okay, so what I'm saying is, Anita, are you with me?
Yes, sir. Please, I'm not in Accra. I am in Western North.
Oh, okay. What I'm saying is, after I hope as for how we were able to get all the figures, you understand up to what we just did, 173 kilocalories. You understand that?
Sir, please,
Yes,
where did
sir.
you get the 28?
Deborah, Mabu. Deborah. No,
Sir, please forgive me.
you didn't sleep well yesterday. So I'm addressing Anita's issue. So let me finish with that, and I'll come back to Deborah. What you are saying is, we've been able to calculate the individual's calories. That is, we were able to multiply 7 by 4, or the 7 was given to us by 4, and we had 28. We've been able to calculate for the carbohydrate, we have 64, that is 16 by 4. Then we also did same to that of fat, which is 9 by 9, and we had 81. So if that is the case, if you want to get the total energy value of that particular bread and that of the peanut butter, we need to add all these figures. Then we added the 28, we added the 64, then we added the 81, then we add 173. Now that you have gotten this, we need to know that the contribution of energy, the percentage of contribution of energy of all these macronutrients to the main food, the contribution of energy by all the macronutrients. And the macronutrients are these three that we've listed them above. And we said that the protein gave us 28 kilocalories. So if I want to get the contribution of protein in percentage, what I will do is I'll pick the 20. Please, next time I do say, can you mute yourself? Some of you, I don't know, been complaining of this. A few months I do say. So what we are saying is, once we are looking for the percentage of each of the nutrients, what we will do is we will pick the calorie of that particular nutrient. We divide it by the total energy in calories. Then we multiply it by 100. Anita, are you with me? So what I did was,
Sir, I get you now.
I took the 28, which was the protein. Then I divided it by 173, which was the total calories of all the three nutrients that is contributing. Then you multiply it by 100. Then Anita, I want to get the answer from you. What did you get when you do that? 28 divided by 173 multiplying 100. What did you get?
Sir, please, I had 16.18 kilocalories.
16.18 kilocalories.
Yes,
yes. No, it can't be kilocalories because we are looking for percentage. So at this point, it cannot be kilocalories.
So what will be there?
That is what I'm asking you. I'm asking you.
Calories.
It can be calories.
Percent.
It will be percentage. Yes, it will be in the form of percentage because the question even said that determine the percentage. I hope you understand. So you can, this particular figure, which is it's always good to run it to two decimal place, which is 1.18%. But we can also run it when it is not up to 5. Our basic mathematics will tell us that you can run it to 16%. Now, I want another person to do for carbohydrates. If you are done, you raise up your hand. Sarah, can you see your hand up? I don't know whether you are done or you have a question. Sarah. Yes, Sarah. Okay, let me go to Cynthia. Let me go to Cynthia. Cynthia, can you hear me? Fika. Cynthia is not talking. Let me go to.
Yes, sir.
Yes, Cynthia, come.
Sir, please, would
Which one? Which one are you working on?
8.9.
Cynthia, which one?
Hello, sir. Please, I'm
I
talking.
can't
Oh,
hear you. I barely
I'm
hear
saying
you. I can't hear you.
that.
Okay, let me.
Sir, with the carbohydrate. Sir, the carbohydrate. Oh, is the network. Sir,
Yeah, I
can
can
you
hear
hear
you.
me?
Go ahead.
Yes, sir. Please, I said with the carbohydrate, I had 36.9%.
36. 36 point what?
0.9.
0.9.
0.9%, meaning 37 points. Yes.
Okay, so approximately 37%. Okay. Any other person? Mavis.
Yes.
Yes, Mavis.
There is the same thing.
The same thing.
37%.
Okay.
Yes.
And Yum. I saw somebody hand up, call it Yum or something. Now let me go to Ernestina answer. Your hand is up.
Sir, I had the same thing, 37%.
37%. Who has who is Francisca?
Sir,
Do you also Francisca?
yes, the same.
Okay. Tilly.
Hello, sir. Hey, the motility now. If you wash a yellow chetumba, we want to.
Hello.
No, we'll feel the madam now. Yeah, and
Yes.
the say what?
Yes, Tilly.
Hello, sir. Good morning.
Good morning. Tilly, go ahead. I think I saw your hand up. Wow, network. Yes, Tilly, can you hear me? Yes, go ahead.
Hey. Hello, sir. For
I
the
can hear
protein I
you talk.
The calculation is 81 divided by 173 times 100. So I got 46.82%, and I
Which
approximately
one? Which one are you talking of?
protein.
Your protein, you had what?
47%.
Hey,
I
Tilly, are you sure?
approximated
Really,
81
that please,
divided by 1.
really, that one is
That
for
one is
fat.
fat.
The 81 is for fat.
It's for fat.
Yeah, fat. Sorry, fat.
Tilly, hey, Obi, I was just pressing now one them.
That's fat, sorry.
All right. That is good. So the fat, come again. Tilly, come again.
By
The fat, you said you
173
had
times 100.
81
For my
divided
fat,
by
173 multiplied by 100, and which gave me 46.82%. So I approximated it.
46.82%. So approximately 47%, right?
Oh,
Approximately 47%. Is that also?
47%. Yes, please.
Approximately. Oh, I'm lying. Now let's see. If you are done with this calculation and you want to be sure that your answer is correct, add all the percentages together. Ramatu.
Hello, sir.
Yes.
Please, I want to find out when you are calculating the 64 for carbohydrate, 28 for protein, then 81 for fat. when you are doing, will you write like the carbohydrate 64? Will you write kilocalories? Then the over 173, will you write the like the total that we got? Will you write something attached to it?
Okay,
Then
when you are okay.
I want to know that. And moreover, the second question is like the carbohydrate, when we got the 36.99, can you just leave it over there, or by force you have to approximate it to the 37%? And
Okay.
then that of protein, when we got 16.18, can you just do it 16.2?
Okay.
Thank you.
I think she's having a fair question. Well, let me start from the last one that she asked. So what you all know is you all remember our basic mathematics, right? We said that when we are doing mathematics, sometimes we do what we call approximation. When you have a figure that is below 5, you can approximate to the lower figure. So let's say I have 2.4%. Automatically I can say I have 2% because it's not up to 5. But when it is above 5, then let's say I have 2.6, then I can run it to 3%. We have been doing this because there are certain instances that there are certain variables you may not be able to have decimals. So let's say you are counting, you are working with human beings, and you said that in my class, 4.6% of the student pass. Can we have a decimal figure? Can a human being become a 0.6? Is it a half human being or a quarter human being? It will be very difficult. So we have a rule in mathematics that you can do that. But when it comes here and you think you want to leave it in a decimal form, you are not wrong. But when you are able to approximate it, it's tell the one or the examiner or it's tell the reader that you really understand whatever that you are doing. That will be the first thing. And also, when you are doing the calculation, you say that is it compulsory for you to bring the calories? Please, as you are doing this calculation, even if let's use the protein for example, if it is 28 kilocalories divided by 173 kilocalories, in our division, our basic mass to division, the kilocalories will cancel each other. You all understand this? I hope you understand. So there will be all those one will not be there. Yes. So you can decide to bring it, and if you don't bring it, there's no problem.
Maybe that sent it there.
Letitia, mute yourself. So if you bring it, fine. But if you don't bring it, we understand. But the most important thing is the final value should have a unit. The final value should have a unit. That is your second question. I don't know whether there was another question. I think you asked about 3 questions. Can you remind me of the other one? I think I've tackled 2.
Please, thank you very much. The one I've asked that, even now I'm still confused about that one, is about the protein. The 16.18%. I want to know if I'm doing it, will I do 16.2 and leave it there? Or maybe in the case of maybe human beings, I have to make it 17 because of that one over there.
No, in the case of human being, you can't make
17.
No, in the case of human being, you can't make it 17 because the 1/8 over there, if you even run the 8, you will get 2. And 16.2 is not, it is not, the 2 is not up to 5. So you cannot run it to 17. If the 2 was above 5, you can run it to 17. So yeah, the best thing to do is you can run it to 16 because the 2 is just below 5.
All right, thank you
And if
very
you
much,
think it
sir.
will also confuse you, you will just leave it like that. You are not wrong. But unless the question asks you, yes, unless the question asks you to run it to probably the nearest either whole number, then that one day you have to run it. The question can ask you like that, run your answer to the nearest whole number. Then that one you can leave it in a decimal form. But anytime you want to write in a decimal form, always leave it into 2 decimal places. If only you want to write it in that way. In mathematics, that is a basic one that that is the standard that we do. We always run it 2 decimal places. That is after the decimal, there should be 2 numbers. That is what we mean by 2 decimal places. All right. I think I can also see Georgette's hand. I don't know whether she's also having any issue. Georgette.
No, sir, I wasn't having issue, but it seems you said that if the one there you can run it out so that you get that one is down. It is less than 5, so that one becomes 0. So the answer will be 16%
Yes.
because it is the nearest this one, which is not up to 5. If it is more than 5, that is where you can run it to the nearest number. But this one is low, so that one will be
Yes.
maintained 0. Then the remaining will be 16%. Thank you.
Thank you. Today, when I'm done with the class, I will look for some of you or mathematics masters, and they have to give me some part of your school fee that you paid, so that I will enjoy it. All right. So let's continue. So with the facts, we said that the fact we had 46.82%. Is that all? I hope everyone had that. Yes, Anita.
Sir, please, would they give us only in grams? What about the other units, like the?
No, we will not give you in other units. We will give you in grams.
Okay.
We measure the
Thank
food
you.
values in grams. Yes, Francisca.
But if you run to the nearest whole number, when you are calculating the let's say the total percentage, it will be easier for you. But
Yes.
when you leave it in 2 decimal places, maybe it may not give you the actual. It will be like I was doing it for this one in 2 decimal places. I got 99.999 for the 2 decimal places. But when I ran it, I got 100%.
Okay, so that is the secret with it. And in mathematics, there's one rule in mathematics that says that your answer is always either +1 or -1. When we are marking mathematics, that is one of the rules. So when you get 100.1%, your answer is right. And when you get 99.9%, your answer is right. So it's +1 -1. So when you run it, the first one is 16%, the second one is 37%, and the third one is 47%. And I know when you put this thing together, you should be able to get 100%. If you are not able to get 100%, then there's something wrong with your calculation. Did you all have 100%?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
So I think today I have achieved my aim this morning. So we are done. Once you have been able to understand this, when you read through the slide, you should be able to do the rest of the calculations. Anna.
So we better go. Let's go on.
You are running away. So this is the solution. I didn't even check whether the solution is even inside your book. So this is the solution. So you see the total was 173. The protein was 28, fat 81. Then the carbohydrate was 64. I think we all had it. So basically that is so you see the calculation that was done here was for the fat, and they had 47%, and we also had this, so we are okay with that. Now let's make progress. Estimating the energy requirement. So we are going to continue. So we say that most people have realized that they need all the nutrients in quantity that meet their needs if they are to maintain health and reduce the risk of disease-related disease. The amount of nutrient needed is nutritional requirement. These requirements are different for each nutrient and also vary from one individual to that of another. And it is also based on your age group, the stage of life cycle that you find yourself. So you should understand this. We are saying that each nutrient has a particular series of function in the body, and some nutrients are needed in a larger quantity than the other. I think we spoke about this the last time that we met, that the macronutrients are needed in a larger amount than that of the micronutrient. And one of the main reasons is the macronutrients are the source of energy to our body. In most of the time, this micronutrient, just most of them assist the macronutrient to perform its function, or others to also perform some vital function within our body. So we say, for example, protein is needed in grams because we need them in a high quantity. That is why they are in grams. And vitamin C is needed in milligram. Vitamin C is needed in milligram. Vitamin C is needed in milligram. So we need to understand this. And aside that, there's another vitamin called vitamin B12. That one is needed in microgram. So what this particular point is telling you is that vitamin C is even needed more than that of the vitamin B2. That is why their own is microgram. That is microgram. And if you have one milligram and you want to convert it to microgram, then basically you have to divide it over. That is 1 million before you'll be able to get it. So it is the grams attached, the unit attached to each of the nutrients even indicates the quantity that is needed for each of them. So we need to just be mindful. And we say that individual requirements of each nutrient are also related to person's age, gender, level of physical activity, and state of health. So what we are saying is, even with the requirement, we look at your age. That is, the amount of requirement you need when you are probably 30 years old will be different from someone who is 3 years old. And also your gender. Remember how we've made mention that men basically require more energy as compared to women. And because of the stature of our body, men, we have a lot of muscles. Unless you are a woman and you decided to become a man, or you did transgender, then that one basically, we can have an argument with that. But at the normal circumstances, men mostly require more, their requirement is always higher as compared to that of women. And we also say that also some people absorb or utilize nutrients less efficiently than others. So we'll have a higher average nutritional requirement. For example, older people have relatively poor absorption of vitamin B12. So that is one of the issues. At certain stage in life, certain vitamins or certain nutrient requirement may be high. When it is high, it doesn't mean that at that moment, at certain point in time, being high means you need them for your body to perform certain function at that particular stage of life. But sometimes there will be an issue of malabsorption. At a point in time when you grow, your intestine become too weak to the point that absorption of certain vitamins become a problem. So example is vitamin B12. So when people get old, vitamin B12 should be something that we need to always make it part of their diet, because the amount you are consuming is, the body cannot absorb all of them. It may be absorbed very little. So if I want to make sure that you don't go into deficiency, then I have to let you be taking it more so that the body will be able to pick them small, and at the end of the day, you may be able to meet your requirements. So do you understand that particular point? Do you understand that particular point? I just want people to understand that at a point in time, your body ability to absorb certain type of nutrients decreases. So if my ability to absorb certain type of nutrient that decrease, then I need to take that nutrient more. So when I'm taking it more, it doesn't mean that I need it more. It is because my body is not able to take the quantity that I'm able to consume. So if you go to hospital and they are giving you drugs, if you want to take injection, if you want to take that drug in the form of injection, read on the injection. You will see that the quantity on the injection is low as compared to the quantity on the tablets that you want to take. And the reason is, when you are taking injection, it goes straight to your blood, and just your body will start distributing it to the part of the body that is needed. But when you take the tablet, it goes to your stomach, digestion will occur before absorption of care. And anytime you take drugs, it is not all the quantity that gets to your body. Sometimes you may take it with some food, and the food may contain certain chemicals, and it will bind the food, it will bind the drug and prevent it from being absorbed by your body. So that one there, it is automatic. So those of you who want to understand this, get the injection that we take in the hospital and look at it equivalent of the tablet that we've been taking. You will see that if the tablet is probably 500 grams, the injection will be around either 100 or less than that. Less than that. So when you are taking it orally, it means that not all of them can be absorbed. And I think we can just use that particular ideology and understand this particular point. And when you are an old person, vitamin B12 absorption become a problem. So we need to understand that. Please, are you with me?
Yes, sir.
Hello.
Yes, sir.
You are with me, right?
You.
Okay.
Yes, sir.
My laptop battery is about to go off. Let me quickly get my charger. I'll get back now. All right, so let's continue. Let's continue. We are saying that the estimated energy requirement is also estimate the amount of energy people need for all life activities. The estimation of this energy is based on your present lifestyle of the people involved and the amount of energy they use while they are less active. So there's a term that we call basal metabolism. Basal metabolism. I know probably these are some of the terms that you need to understand in this particular course. Basal metabolism, we are looking at the energy that your body uses when you are at rest, when you are less active. We call it basal metabolism. So when you are sleeping, your body uses, don't think that when you are sleeping, your body doesn't use energy. When you are sleeping, your body uses energy to breathe. Most of you eat at late. Your body uses the same energy to digest certain type of food. Your body uses energy for respiration. All this energy that the body uses when the body is not active, we call it basal metabolism. Basal metabolism. So put it in mind. So basal metabolism, you can simply put that it is the amount of energy that the body uses when it is less active or when it is at rest. And we are saying that the energy value are based on relatively low activity so that people may not be able to affect even if they exceed the requirement. So we need to understand that. And we say that energy requirements are related to age, gender, weight, height, and level of activity. So what this point is telling you is that when you have a tall person, the person energy requirement may be higher than someone who is very short. Because when you are very tall, it means that you have a lot of the cells and also even the length of your bones and everything may require energy. So it is your height also influence the amount of energy that your body require. Also, your level of activities. Someone who is physically active will need more energy than someone who is bedridden. Someone who is sick and the person is bedridden. The person is always on inside bed. Basically, that person may not need more energy as compared to someone who is very active, who is hawking on the market, pulling track and the rest. All this activity contribute to the level of energy requirement that you need. And also, we say that, however, on average, boys have slighter energy requirement than that of girls. And I think this one, I have made mention of them consistently that anytime you should put it in your mind that we male, we require more energy as compared to female. And one of the key reasons I gave is we possess a lot of muscle tissues. there is a lot of muscle tissue, and you female possess a lot of adipose tissue, and adipose tissue are basically those places that fats are stored. But with the muscle tissue, most of our energy or the glucose that has been converting to glycogens are mostly stored in our muscle tissues. And once we have more muscle, it means that our body will be able to store more energy as compared to that of you female. So just have that in mind. And we said that energy requirement tend to increase up to age 15 to 18. And I think that this one, it makes sense. When you are in an adolescent stage, your energy requirement tend to go high because at that point you are developing a lot of hormones, your physical activity is very high. You do a lot of, you involve yourself in a lot of activity. Those of us, I think most of us are teachers, so we understand this. Look at how children within adolescence, how they involve themselves in a lot of activities. So we need to, and we said after 18, energy requirement tend to be lower. But again, it depends on the individual level of activity. So after 18, probably the body has been able to build most of the hormones, the enzymes, and the development of the body, most of them has been done at that stage. So the energy requirement tend to slow a bit. But as it's slow, it's also depend on the work that you do. That is your physical activity. So if you have, what is it? When you are in the school, you have a math and science quiz team. Then you have the athletics team. Those students who are in the athletics team will require more energy as compared to those in the math and science team, because the math and science team, although they need glucose for the brain function, because they learn a lot, they do a lot of this learning, but those in the athletics team also do a lot of physical exercise. And you know, when you are doing physical exercise, your energy source can easily be depleted. So that is the few things that we need to also understand. We say that by age 50, energy requirement reduce markedly or rapidly due to reduced basal metabolism rate. And I think we all know what basal metabolism is. But this here, we are not talking about only the basal metabolism. We are looking at the rate. We are looking at the level at which the body uses energy for when it is at rest. So this is what you need to understand. And we say that in calculating the estimated energy requirement, basal metabolic rate is multiplied by physical activity to determine the person's daily energy. Hello, let's come back again. We are coming to do some calculation again. Now we are coming to look at your basal metabolic rate. Your basal metabolic rate, we are telling you that it is the amount of energy that your body, or the rate of energy that your body uses to perform its activities. So once we know that, and we want to know the total energy that you require, we will look at your basal metabolic rate, then we will multiply it by your physical activity. So someone will ask, how will you determine physical activity? There is a predetermined values. There are people who perform certain type of work has been grouped. So as a teacher, we are less active, or we can place that as moderate, because some of us will walk in a long distance, and a value has been attached to that. Those who are into who are doing a strenuous physical activity, a value has been attached to that. Those who are just bedridden, a value has been attached to that. So when I multiply that value to that of my beta metabolic rate, then I will get my total daily energy expenditure. Hello, are you with me?
Yes, sir.
Yes, sir.
You are coming to do calculations again, no?
Yes, sir.
All right. So this is the basic metabolic rate. Say that the BM is the total amount of energy that the body needs to perform basic function, without which life may cease. What are some of the basic functions? Circulation is one. Your body needs to circulate nutrient and blood, water all around your body. Breathing is one. Cell production is one, and among others, digestion and others, they are all basal metabolic activity that's happening in our body. We say that the BMR rate is the rate at which the body uses energy for basic function. I think I spoke about it. So these two things, there are difference. There's difference between the basal metabolic. Then there's a difference between basal metabolic rate. The metabolic itself, the basal metabolic, we are looking at the total amount of energy that your body uses to perform certain functions, that when those functions are not available, your body will cease to exist. That means that you will die. When you wake up in a day that your body cannot circulate blood, it cannot also breathe, you cannot produce cells, you cannot digest food, then respiration cannot occur. Then basically, you cease to function as human being. But when we come to the rate, we are looking at the level. Rate means always the level. This day we said that the dollar rate is at 10.5, 10.9, 11. We are looking at the level rate. So we say that the basal metabolism rate is the rate at which the body uses energy for basic function. So the rate at which my body will use energy to perform these basic functions are different from the rate at which your body will use it. Please, do you understand the differences? You get the differences? The basal metabolism and that of the rate. Do you get the differences?
Yes, sir.
Please, if you don't get it, let me know, because I'm going to
Sir,
be
please,
using
can
them
you
for.
go over again, please?
Okay. What we are saying is, within our body, anytime you are at rest, you are not doing anything, the body still undergoes respiration. The body still produces cells. The body still finds a way to breathe. The body still finds its way to circulate blood throughout your body. That is why when the blood is not sent to a particular part of your body, you feel like that part is dead. So someone will say that I'm in 9. It is a way that is giving you an indication that there's a problem. The blood is not flowing through that particular area of your body very well. And we are saying that the energy that your body uses to perform all these functions, we call them basal metabolic energy or basal metabolism. Basal metabolism. And we know that metabolism is mostly about breakdown of energy, nutrients in our body. So the energy that your body uses to perform the breathing, the circulation, the production of cells, digestion, and the others. When we put all this energy together, we call them basal metabolism. Basal metabolism. That is what we need to understand. Then we also have what we call basal metabolic rate. And because we are at different stage of life cycle, our activities are different, our body stature is different, we belong to different gender group. Our body doesn't use the usage of energy is not the same in every human being, or the level at which your body will use certain energy to perform certain functions is not the same. So let's say, let me use someone like Yaudabo, who is very short. That's or those short people that you'll be seeing them on our screen, as compared to a very tall person. Whom should I use in Ghana? Let's say, let me use someone like President Kufuor. You know, the man was very tall, or he's very tall, probably. The level at which, if the body want to circulate blood within the body, let's compare these two people. Because President Kufuor is very tall, the body will use more energy in order to get to the head. If you want to circulate blood, we know that blood carry all these nutrients that we've been talking about. So because he's very tall, the body will need more energy to push the blood up to that height. But someone who is very short, the body will need a little energy, the body will be able to reach that particular height. And that is giving you the rate at which your body uses this energy. That come out with the BMR, the rate. So it means that President Kufuor will need the rate at which his body will use this energy for circulation will be high as compared to that guy, that actress or the comedian called Yaudabo. Please, do you get the analogy I'm trying to use here? Do you get it?
Yes, please.
Do you get it? Yes. And someone who is very fat. Let's look at these people, the Diasa people. The Diasa people, let's use them for example. look at their body size. So if the body wants to supply nutrient to all the body size, it will never, the amount of the energy that the body will use, it will be higher as compared to someone who is very slim. Because the body size, you need to push a lot of energy before most of the nutrients will get to that point that you want it to get to. So that is the idea that I'm trying to sell to you this morning. Do you understand it now? The one who has the question, Cynthia. Was it Cynthia or a Chan? All right. So let me continue. And we are saying that the calculation of BMR, that is the basal metabolic rate, the individual vital statistics such as age, gender, are used and multiply with some predetermined values. Yeah, they go.
Hello, sir.
Yes.
You said when we compare a slim person to a fat person, the amount of energy the fat person will need will be more than the slim person, if I got you right.
Yes.
But sir, I've seen some slim person, the person eats more than the fat one. Oh. That one, what causes it?
You are getting the analogy wrong. The amount you eat doesn't correspond with your requirement. I'm talking about your requirement. There are people that naturally they eat a lot. You know, when you have a body size that is big, it means that you have a lot of cells and tissues. So it's the cells and tissue that come together to build your organs and become your system. If you look at the level of organization, we have cells, tissue, organ system, then we have organisms. So once I am fat, I am very big. It means that I possess a lot of tissues more than you. And each tissues require some energy to perform its functions. So if my tissues are more than you or my cells are more than you, automatically I will need more energy than you. But here is like you are saying about food, the consumption. There are some people, they can eat beyond your imagination. Eating too much doesn't mean that is your requirement. No. The way where we eat are influenced by a lot of things. Some people, when they are happy, they eat a lot. Some people, when they are in anxiety form, they eat a lot. Some people, when they are in the sorrow state, they cannot eat. So what triggers us to eat certain type of food or the amount of food we eat? Probably even the taste of the food can even influence the level at which you eat. So that is what we need to understand. Yes, Anita.
So with this eating thing, when I gave birth to my boy at the hospital, when he was 6 months, his weight, maybe when he was weighing 7 kilos, a child of the same month was weighing maybe 4.5 kilos. But when you look at them, my child was very slim. But when you look at the other child, he looked very big. So I was thinking that, hey, so how do they make it? And then they explained to me that it's not about the physical appearance. When you lift the person up, you could see that he weighs a lot than the one with the lower weight. So I don't think, like you were explaining, the more that you consume it's influenced by like your physical appearance alone. Thank you.
All right. I'll make a comment on that. Let me go to Francisca.
So, why is a question? As you said that when you are fat, your tissues they will require more energy. So, could it be wrong that sometimes maybe, let's say you say that you are fat and you reduce your food intake? Can this not in one way affect you? That's the question.
If you want to reduce weight, that's what you are saying.
And I'm saying that, as you said, like it's like those they are fat and they are sore, they require more energy. And I'm saying that in the quest of saying you reduce weight, can't it affect you that maybe you may be taking less than your requirements, what your body requires?
You see that? Okay, I get your question. The most important issue here is your basal metabolism. how your body is able to use energy to perform basic functions. And remember that when you are also too fat, if you don't try to reduce weight, you are putting a lot of pressure on your body in some situations. I hope you understand. So so you may be required to reduce weight in order to probably even help your body to perform better function, because too much fats sometimes interfere with a lot of the hormonal and enzymatic activity within your system. So when you are trying to reduce weight, we try when you get to the dietitian, they have a policy that they use that when you meet someone who consumes 3 balls of banku in the morning, you don't tell the person to start taking 1. No, the person will not be able to do it. So if it is 3 now, let the person take 2.5. With time, the body will adjust, will know that this is my level. Then you reduce it to 2 again. With time, the body control, you reduce it a bit by bit to the point that the body, even if it is 1, the body will understand that this is the energy that is always available to me. So this is how I'm going to I use it. So you may not have issues. You may not have the initial stage, maybe hunger issues and stuff will come. You feel hungry, but you have been restricted. So you find a way to give you food that contain what we call the complex carbohydrate that will prevent you from feeling that kind of hunger, and with time you'll be fine. And also the one who was saying the issue of weight issues. Yes, what you said was right. When we are talking about your body weight, it is not determined only by your physical activity or your physical looks. Sometimes we call something that we call bone density. How heavy your bones are. You also contribute to your what is it? Your weight, and also your muscle mass. People who have a lot of muscles, their own is quite better than people who have a lot of adipose tissue. So a woman who is fat compared to a man who has gone to gym and develop a lot of muscles, that woman will weigh better or higher than that of the person who has been to gym, because most of the time when you go to gym, the muscles that you develop, we call them the lean muscles. It doesn't contain a lot of fat. So that is what we need to just understand with that. I think I can proceed now. Now, if you want us to calculate for our BMR, there are some formula that we use. There are formulas that you use. I don't know whether I remember someone asked me last year, those who completed your seniors or someone, so say, are we going to chew all these formulas in our head? I hope you also have the same question to ask. So this is the formula that we use if you want to calculate. There are a lot of them. There are a number of those formulas out there, but we can focus on our own or the one that has been given. So if you want to calculate it,
Yes, sir.
you consider your age. Yes, Mary. Yes, Mary, what is it? Okay, let me go on.
Please, no
All right.
question.
So if you want to do the calculation, this is the formula that we use. So we say with men, the formulas are 2. We have one for male and one for female, or men and that of women. So with men, we do 66.47 plus into bracket 13.75 times your body weight in kilogram. Put that one in mind, in kilogram. So even if a question is given to you in pounds, you need to convert it to kilogram before you can use it. Then plus into bracket 5.003 times your height in centimeters. Your height in centimeters minus 6.755 times your age in years. Then you get the BMR for male. So you see, there are certain factors that you need to compute in order to get your answers. That is your body weight in kilogram, your height in centimeters, and that of your age in height, in years. So this is it. And let's look at the female or the woman. 655.1 plus 9.563 times your body weight in kilogram plus 1.85 times your height in centimeters minus 4.676 times age in years. So these are the formulas that we use to calculate our BMR. So when you compare the male and that of the female, you realize that the figures has reduced a bit when you are comparing the female one, because the male one is higher than that of the female. And we have said that men mostly have a slight higher, energy requirement as compared to female. Okay, there may be an exception. Yeah, that's me.
You were saying that for the formula, the men theirs is lower than the women, but when you look at the initial number,
I said
the
higher.
men it is the men are higher than the women.
And that is what I said, higher.
Say, but I'm saying that with the initial number for the men, it is 66.47. And then for the women, the initial number is 655.1. So you can see that the difference is the initial numbers, the difference is wide. So how can it be higher than that of the?
Okay. So look at it. I was using the numbers, the variable that you are going to use to multiply. The number that you are going to use to multiply your variables. That is where I was speaking from. So your variables are your weight, your height, and that of your age. Now look at the numbers that you are going to use to multiply each of them and compare to that of the women.
Yes, sir. That one is higher. The men have the higher numbers.
Yes. That one is higher, and because that is the main variables. Although with the formula you can see that the female one is 655, and the male one. But because this year deal with multiplications, those numbers are going to be very high. Well, imagine if my age is 65, and you are multiplying 65 by 13.75, and yours is 65, and you are multiplying by 9.563. So you can see the difference. It's the same thing with the height. This one 5.0 and the woman is 1.85. You can see the difference. Here is 6.7 and here is 4.6. So that is what I'm trying to say. So this is our two formulas that we are going to use. And there's another formula. That one is the inventor is called Mifflin St. John. Mifflin St. John. We have I think the first one is the Harry Benedict formula. The first one that I just said. I think that is his formula. We have Mifflin St. John. We have Henry Benedict. All these people are the nutritional scientists who developed this formula for us to be able to calculate people BMI. So with his own, he said you have to multiply 10 by your body weight, then you multiply 6.25 times your body height, then you subtract 5 5 times your body age from it. And he said that where S is plus S, so and he has defined the S here. He said that where S is 5 for male and minus 161 for female. So that is it. So the S over here, that variable S here has given you that if it is a male, it is plus 5. If it's a female, it's minus 1. 6.1 for female. So these are some of the formulas that you can use to. I hope you have quoted the formulas on your sheet of paper that you are with, or you have. I think you have the slides. So basically, you can use it for that. Okay. So let's look at this. There's an assignment here. We said that use your vital statistics. That is your age, your gender, your weight, and your height to calculate your BMI. Do you all know our vitals? Hello? Do we know our vitals? Who is saying no? Don't you know your vitals? You don't know your age. You don't know your height. You don't know your body weight. Don't you know these vitals?
Sir, please, we know.
Okay, someone should come
Sir,
with
please,
a
not all of us.
sure. Then go and find out. This time, these things are basic things that you need to have it. So someone should come out with her vitals or his vitals, and let's use it for the calculations. Someone should come with his or her vital. Mumfama, who
So
is
let,
giving
let
us
me
her
come
vital?
with my
Okay.
say age 41.
Your age. Mm-hmm. Your
41.
age is 41. Uh-huh.
Yes. Height is 1.67.
1.67
7.
centimeters. Mm-hmm.
Yes. And then my weight is 69
69 kilogram.
kg. Yes.
Mm-hmm. Okay. So you are a female, right? Are you a female or
Yes.
male? Are you a he or him?
I'm a
Or she? Are you she or him?
I'm a she.
If you are not able to tell us your gender, you may choose a wrong formula. All right. So now we can quickly use. Let's use the first formula that I give. So let's go in for the woman. Everybody is calculating on me. I'm going to do mine here. So we should all do the calculation. Let's all do the calculation. So we are using the 655.1 plus. Please remember in mathematics, anywhere you see the brackets, put the bracket there. You are going to do board mass. Do you remember your board mass? And there must be a way hand. Only God knows. So let's do it. I'm also doing it. So I'm giving you like 2 minutes. Let's do it.
Sir, please, her height again.
Her age is
Please,
41 years.
the
The
height.
height is
The height.
1.67 centimeters.
1.6.
1.67 centimeters.
1.67. Oh, okay. Thank you.
Then the weight is 69 kg. Then she. So let's start. The weight is 69 kg. 69 kg.
Sir, please, what about the height?
The height is 1.67 centimeters. 1.67 centimeters.
Thank you.
All right. Yes, centimeters, cm. Tilly. Oh, I don't know how to tell you. I didn't fit. Obi aka fit wa. I don't feel.
Please, what are you calculating? I was offline small.
What do I mean? If we are offline, we have been given an assignment that is on the screen. So look at it and work on it. We have been given an assignment. Who is done? Who is done? Yes, rejoice.
Hello, sir. We
Uh-huh.
have 1,594.99. And sir, please,
Let me write 1,500. 1,500
and
and what?
94.99.
94.99.
Okay.
Okay.
Sir, please, I want to ask this question. What will be the
Uh-huh.
unit in which we will leave this answer?
The unit is kilocalorie.
It should be in
That's kcal.
kilocalories.
Yes, the unit is in kcal. Yes.
Thank
Yeah,
you,
I
sir.
saw Helen. Helen, your hand.
Sir, I had 1,126.324 kilocalories.
1,100 and
26.324 kilocalories.
324 kcal. Okay.
Yes, sir.
All right.
I also had
Interesting figures.
1,126.
If I have not called you, you can't talk in this class. You have not been called. You can't talk. If you want to talk, you raise up your hand. Esme is next. Esme.
Sir, please. I also had 1,126.3 kilocalories.
1,126.3
26.3 kilocalories.
kilocalories. Okay. Efia.
Sir, please, I also had 1,126.32
kilocalories.
Okay, 1,126. Okay. Yes, Mavis. Mavis.
I also had 1,126.3205 kilocalories.
Okay. Yes, Ramatu.
So I also
Yes,
had
Ramatu.
1,126.32 calories.
Okay. Patricia.
Please, I got 1,126.3205 kcal.
Okay. Any other value aside this thing, the two that because we have gotten 1,594 and yes, patient. You have different value.
No, please,
Hello,
I
patient.
had one.
Please, if you have gotten any value, if you have gotten any value, it's better you tell us or you read it out so that all of us will go through. Then you identify the one that is correct. Don't just sit idle and be following what others people have gotten, because I know most people have gotten 1,126, so you may automatically join them. So far as everybody is getting that, doesn't mean that that is what you are also supposed to get. You are supposed to also get your own. Yeah, any other value aside what you've said so far? Any other values? Okay. Let me start with the one who had 1,500. 1,594. Who said that? The first person, I think I Rejoice, right?
Yes, sir.
Rejoice, how did you arrive at that? So you are coming to tell me the process you used. So the formula that we were using was the second one, which was for the woman. So it was
Yes.
it was 655.1 plus. I hope you are following. Okay, read out yours for me. Let me rather get it from yours so that we will know where how you were able to arrive
Okay.
yours. So
Sir. 655.1 plus into bracket
Go ahead.
9.563 times 69 plus into bracket 1.85 times 1.67 bracket close. Okay, the where I had the problem was I used plus instead of minus. It's true.
Very good. Very good.
Thank you.
Then do it again and let me know the answer you had.
All right, I'll do.
I think about six people had 1,126 kilocalories, and that is what I also got when I finished my calculation. I had 1,126 kilocalories. Georgette.
I think I have 1,136. So
36. Then check
yes,
your calculation again.
1,136. Okay.
Check your calculation again, because from my end I had 1,126 kilocalories. So any figure aside this, probably there was a. But and remember your board mass. Do everything in the bracket. After that, then you do the additions. Well, I think those who are not talking, I'm assuming that you all had the same thing, because we are doing calculation and you are saying you won't talk, or you've all gotten the same thing. Everybody should type their figure inside the comment section and let me read them.
Hello, sir.
Yes.
Please, me, I didn't do the one in bracket first, so though I got the answer right, 1,126.3205 kilocalories. But me, I just typed the whole thing with bracket and everything. like that into the calculator and it came. So is it that sometimes if I do it that way, I may get it wrong?
If you have a better calculator, it will do it for you. Me, I use my phone as a calculator to do it, and I can't type everything inside it like that. I hope you understand. But the best thing is, we are also supposed to understand the process, not just computing everything into the calculator to give you the
So I've now got it. 1,126. Hello.
answer. People understand.
Sir, I have
Yes.
gotten it. I got
Okay.
1,126. Okay, thank you.
All right. Any other issue? Afia? Yes, Afia, your hand is up. Those of you that didn't
Sir,
talk,
please,
type it at
there's
the
a
comment section. I want to see them. Those who didn't talk, I want to see all your answers on the comment section. So it means we are good to go. Let's use the same calculation or the same vital for the male. Calculate it and let me see. Use the same vital for the male. Use the male formula. The same vitals. Use it and let me see. You have 2 minutes to do the calculation. Use the same vital for the male. Have you finished?
Yes, sir.
Come out with your answers. Yes, Vivian. Yes, Vivian.
Please, I had 1,436 kilocalories.
I can't hear you well. Can you louder?
436.
1,400 and
36.
1,436. Okay.
436 kilocalories.
Point what?
So the point is less than 5. It's
No
2,
problem.
so
No problem.
So I
No
have-
problem. So 1,436 kilocalories, right?
Yeah.
All right. Yes, Letitia.
Yes, sir. I had 1,382.
1,382.
82.32.
Okay, so let's ignore the point and kilocalories.
Okay. Okay.
1,382. Okay. Yes, Rejoice. Yes, Rejoice. Yes, Patricia.
Listen, I
Mhm.
got 746.1951
Hello, sir.
kilocalories.
700 and
46.
746 kilocalories. Okay.
Hello, sir. Rejoice.
Yeah, Rejoice.
746.62 kilocalories.
746. Okay.
0.62.
All right. 0.62. So we can run it to 747.
All right, sir.
Yes, Esme.
Sir, please, I had 746.83 kilocalories. So I can run it to 747.
747
47 kilocalories.
kilocalories. All right. Efia.
So please, I also had 746.62.
Georgette.
So I had 746.62, but I ran it up. So 747.
All right. Mavis. Mavis
Sir, I also
Achampong.
had 747 kilocalories.
All right. Susanna.
So I had 746.6
All right.
kilocalories.
Okay, good. Mavis Akoli.
The same thing, 746.62. And then I ran it up to 747.
All right. Okay. So it means yeah, Ramatu. Yes,
Hello,
Ramatu.
sir. Please, it's the same thing. 746.622. So I ran it to 747. Thank
So
you.
it means we have gotten almost about 7 or 8 people getting the same answer. Basically, me, I didn't do the calculation. I didn't do it. Let me tell you the truth. So, and one person had 3,436. Another person had 1,382. So I want those people to take us through how they were able to arrive at that particular figures. Who had 1,436? Who had that?
That's me, Vivian.
Can you take us through how you arrive at that particular figure?
So the first we did, I also had similar answer. That's why I did not talk. That one too, I got 1,336.4. So I don't know if my calculator is not helping.
No.
I calculated.
Did you write it step by step, or you just figured everything into a calculator?
The second one, I figured everything into the calculator. But the first one, I did the bracket system before adding up the numbers. But so I had it. I got 1,336.
So you see the problem here. I wanted you people to just write them systematically. Putting everything into the calculator is one of the laziest way of doing mathematics. So I'm sorry for my language, but I have to say that because if a question
that's okay. That's okay. I use the system now. Yes,
yes,
41. Oh, okay.
if a question is given to you and you put everything into a calculator, then you come out with the final answer. Probably you get the final answer correct, but the process
7
that you have to follow in order to get the final answer also contains some form of math. So you may lose that. Is that okay?
Okay, so that would be.
So I'm assuming that the 746 kilocalories people are right. Is that not so? Yeah, Cynthia, any question?
Me pasó mi mucho.
So I blame on.
Those who got 43. If we had it wrong, they should take us 3%.
Okay, so those who had Mavis, you had that. So take us through. Mavis, a champion. Take us through. Obise so I blend in munya mutra where say. Where is Mavis? Any other person who had that? Georgette.
Yes, sir.
Take us through.
Okay, sir. All right. Because the person's the age was 41, then the height was 1.67, then the weight was 69. Then we are using the men's own or the male, and the males their formula is 66.74 plus 13.75 multiplied by the weight, which is 69 plus 5.003 times whereby you are multiplying by the height, which is 1.65. Then you have your minus sign over there, bracket open, 6.755 times the age, and the age was 41. So you do the bracket first. So 13.75 times the 69 will give you 948.75.
94, come again.
Then
94.
948. 948.75 plus the 5.003 times 1.76 will give you 8.3550. 35501. That will give you the answer. Then you bring your minus sign there. Then you work for the one with the age, which is 6.755 times 41. So when you multiply 6.755 times 41, you get 276.955. That is where you sum everything up over here. So the first digit was 66.75 plus 948.75 plus
66.47.
66.7. Yeah, sorry. 66.47 plus 948.75 plus 8.3550. You get 1,023.57501. Then you deduct 1,023.57501. Then you deduct it from 276.955. You will land at 746.62. But because the space there is more than 5, you can run it up to the 6 to the digit number which is nearest to the 6 over there. So you are going to land on 7.7. That is how I got it. Thank you.
Any other person who did the same thing? Do you all have the same figures during the process? Do you have the same figures during the process?
Yes, sir.
All right. I think someone said that she doesn't understand. Can she come again? I've forgotten the name of the person.
Yes, sir, I was the one. Cynthia, please, I don't understand.
You don't understand from where? Is it the whole formula? Have you been online up to this time?
Yes, sir.
And where did you get the problem from? Because looking at the pace that I'm going today, I don't think I've ever taught this pace before. Where is the problem coming from? Because
Sir, please, with the formula, you know the woman's own is say 5.1 plus the digit that is there. So are we going to multiply by the weight the woman gave us, or that's where I'm confused. The one I multiply, what I got,
what was the weight that I gave you?
the weight was 69.
69. So multiply the woman, multiply 9.563 times 59, give me the answer you had.
So I had 659.
659.8. 0.8. Mention all. You just mention everything.
Okay. 659.847.
Then put it into bracket.
Okay.
Then you move to the next one. The next one says multiply 1.85 times the height. What was the height that I gave you?
So the height was 1.67.
1.67. So multiply it by 1.67 and tell me what you had.
Okay. So please, I had 3.0895.
Put it into bracket. Then go to the next one. Minus.
Okay.
Multiply the 4.676 times the age. What was the age that was given to you?
So 41.
So multiply it by 41 and give me the response.
So please, that one too, I had 191.716.
Then where you have gotten to, you just need to do what you call addition and subtraction. So you add the 6.655.1 plus what you had at the first bracket. You say you had 659.847. Is that also?
Yes, sir.
Yes, you add the first one, which is 655.1 plus 659.847 plus the one in the second bracket, which was 3.0895. Add the three together and give me the answer. Add the three together and give me the answer.
Okay, sir, I'm adding.
You have kept long. Why are you using proper calculator on your phone?
Sir,
Mm-hmm.
please, I had 1126.
You had 1-1. It can be possible.
26 point.
It can be possible.
Hello, sir.
Yes.
Please, when I tried to do that one, I had 1023.57 something.
No. Well,
So
you people.
the thing is, when I did 66.47 plus 948.75.
Please. The one talking, the one I'm working with her, she's doing for the women. Let me finish with her before you bring the mail and come and confuse us. I beg you. Where is Cynthia?
Sir, I'm here.
Cynthia, pick your calculator. 0.655.1. Have you done that?
Yes, sir.
Plus 659.
659.85.
0.847.
Okay, I've done it.
Plus 3.0895. Is that not the figures you had?
Yes, sir.
And when you add the three, what did you get?
Sir.
Please let me finish with her. I'm coming. What did you get? Cynthia.
Sir.
Sir,
please, I had 1318.0369 SS5. So I'm now coming to subtract it by the.
Yes, write it down
By the
and
191.
Good. Write it down and subtract 191.716 from it and tell me what you had.
Hey, sir, oh my calculator, I got 1126. Oh my calculator is not helping.
So your calculator has done what? The calculator has given you the correct answer and you are saying it is not helping you. Can you do it without a calculator? That is the correct answer. That's for the first one. Yes,
okay.
for the first one, it's 1126. That should be. So the problem is probably when you were doing the calculation, you didn't do it. That is why you say you don't understand. Because this is just some basic mathematics we are doing. And one thing that you have to understand is if you people make mistake with a point, you see there's a lot of points in it. The decimals are many. So if you don't put it in well and you do your own thing, you may not arrive at the correct answer. Are you with me? So use the same process and do for the male. Use the same process, the same vital for the male. And tell me the answer later because you don't want to leave anyone behind. Somebody, I think patient or something, you wanted to say something. I wanted to finish with her before. Okay, so if there is no any other thing, let me continue. There are other things that we need to do. Our time is somehow limited. Just that I just wanted you people to do the calculation very well. Ask me, yes, come again.
Sir, please, I want to ask a question.
All right.
We know that I would say that the standard energy that everyone is supposed to get, depending on the level of activity, is around 2,000.
All right.
So the sedentary workers, we know, like for them, they don't do anything. So it's around 1,000 for 2,000 is accepted. And then the other activity levels. And then the highest is around 2,800.
Okay.
So for the female, the one we calculated, if the person gets around 1,126.3 like we got, and then the male who is supposed to have a higher number is having 747. Are they not malnourished?
No, they are not. What we just calculated is not their energy requirement. What we just calculated is their BMR. Put it in your mind. What we just calculated is their BMR. That is the basal metabolic rate. But if I want to get their estimated energy requirement, then I have to multiply it by their physical activity. Are you with me, Esme?
Yes, sir. I'm following.
So we are not yet done calculating for their estimated energy requirement. No, what you just did, this is the energy that you need to perform your basic function when you are not active, such as the circulation, breathing, digestion, production of cells, when the body is at rest. That is what we just calculated. And one of the reasons why probably the male one is a little bit low than out of the female. We didn't use the right vitals because we just use the female one to do the male one. But if you get a male and we take his actual details and figure it in, probably it may go beyond that. Are you okay with that?
Yes, sir. Thank you.
You're welcome. So let's see. Yes, patience. Mama want to answer.
Sir,
We will not finish. Oh. Yes.
sir, please, the St. Joel formula.
Mm-hmm.
They said for male is 5.
Mm-hmm.
And then the female, I wanted to know whether the number there is negative 161 or is positive.
Yes, you subtract it. So with the female, you subtract 161 from it. So at your free time at home, you can use that particular formula to also do some calculation on that. Just that there are a lot of formula. We just brought 2 for you to just appreciate them. And once you are able to do the first one, I think the second one won't be a problem. Is that okay? Yes, Ramatu, what is it? Ramatu, tell me what you want to tell me before I proceed. Since we are running out of time. Uh-huh.
Please, when Madam Esme was talking, I don't know whether maybe when we finish calculating, I was thinking we'll put kilocalories there, but I heard you mentioning something different.
Which one are you talking about?
Calculation we just did. This one we just did for men and the man and then the woman. When we finish, like the 746.6200 got, are we putting kilocalories attached to it, or what are we putting attached to it?
I think I have answered this question in the class. That is why you need to pay attention.
Yes, I heard you saying we are putting kilocalories, but because you also mentioned BMR, I don't know.
The BMR is what we calculated for, and the unit is the kilocalories. Please don't confuse yourself. The BMR is what we calculated for. BMR is your basal metabolic rate. And the unit is the kilocalories. Are you with me? All right. So let me proceed. So the assignment, we said I use your own vital. So just you can do it and let's see what you will get. And we said that anytime any resource, we said that anytime the resource is increased in metabolic rate, this include exercise, stress factor, and illness. So one thing you need to understand is when someone is ill, there's a possibility that your body will use more energy as compared to someone who is not sick. Cynthia.
Sir, please, when I inserted with the men's phone, I had 746.62.
You are correct. You are correct.
Thank you,
So
sir.
what happened was when you were doing it, you were not also doing your own. That is why you lost in the forest. So make sure you don't go back again. I beg you.
Okay, sir. Thank you.
Okay. So what you are saying is physical activity level is one of the means by which a person daily activities is expressed as a number of factor. So we have 1.4, 1.5, 1.6, which reflect the lifestyle of most people in the UK. So we said this factor is usually used for people who do little activity. So people who do less physical activity or work, or they are mostly or in their leisure time. So we say that if people are more active, a larger figure may be, or factors may be used. So for example, a physical activity of 1.9 would be appropriate for a very active adult as shown in the table on the next slide. So after calculating the BMR, using the Harris-Benedict formula, which was the one that we just used, may be used to calculate total daily energy expenditure, that is the TTD. And it should be noted that the TTD is viewed as the estimated amount of energy required for a normal, healthy person who wants to maintain his current weight. Or if you want to maintain your current weight, after getting the formula, after calculating your BMR, you multiply it by your physical activity. So we said that that's the total energy expenditure, which is TDDE, or is equal to the daily energy requirement to maintain a neutral energy balance. And you remember a neutral energy balance, when we were talking about neutral energy balance, we said that if you want to maintain neutral energy balance, it's at a stage whereby your intake is equal to your output. Whatever you take in is what you spend. So if I want to calculate or I want to estimate my energy requirement, it is equal to BMR times your physical activity. So the BMR is the one that we have calculated for the both male and female. So let's say this is a what is it? The table. People who do extremely inactive cerebral palsy people. This cerebral palsy, they have problem with their brains and they are always bedridden. So their own is always less than 1.40. Then sedentary workers, people who work in the offices, they have no activities. It's 1.4 to 1.69. Moderate active construction workers or person running 1 hour daily. Maybe you try to exercise yourself 1 hour a day, or you're a construction worker, 1.7 to that of 1.99. Then those who are rigorous activity, agricultural workers, that is they are non-mechanized. Non-mechanized means that they don't use machines, they are using their body themselves. People who swim for about 2 hours within the day, their own is 2.0 to 2.40. Then we have extremely active, that is competitive cyclists, those who go for this competition, cycling, footballers, people who go for jogging every blessed day. Their own should be greater than that of 2.4. So this is what we are going to use. So let's choose a figure from here. Let's say the woman that we calculated the energy requirement, she is probably someone, she's a sedentary worker like a teacher. Let's put it that way. Teacher will be probably a sedentary worker because we don't do much activity. And because when I choose a teacher, I can say that I will choose around 1.5 because probably the teacher will walk to school. So there's a little activity in there. When you get to the class, you move around. There's a little activity. I can choose 1.5 or 1.55. So let's say we are using 1.55 as your physical activity factor. So I'm going to multiply the value that we had, which was 1,126 kilocalories by this let's choose 1.55 times 1.55. Do the calculation and give me the answer. Do the calculation and give me the answer. What did you get? What did you get? Yes, patient. Patient, what did you get?
Please, I didn't get the thing well. My network was doing some scratches.
You are doing calculations, so a lot of excuses may not help.
Sir, please, so
Just
our network, please, the question again. Which one are we using?
what I said, you should use activity factor of 1.55. 1.55. Yeah, Georgette.
Sir, please,
Okay, so I got
1,745.3. 8.
So kilocalorie.
Yes.
Rejoice.
I had 1,745.3 kilocalories.
Okay. Any other person? Then let's also use this factor. Let's assume that the woman is an agricultural worker. That's me.
Sir, please, some of us, our network was not good. So those who had the answer, can they give us, like, walk us through how they got the answer, like the formula they used to get the answer?
There's no formula. There's no formula. What I said was,
Yes, sir.
Myself, I didn't get this. Walk us through.
oh, you are making the work difficult for me now. What I said was,
Yes,
if
sir.
you are, when you get your BMR, and we have all calculated our BMR. So if you want to get your total energy expenditure or your estimated energy expenditure, just multiply your BMR by the activity factor, your physical activity factor. That is the
Okay,
only
sir.
thing we are
Thank
doing
you.
now. We didn't
Okay,
do
sir.
any formula again.
Okay,
Right.
sir. So, sir, we did that of the woman. Okay.
So the woman, I gave you 1.55. I said, let's assume that she's a teacher and she doesn't involve herself in any form of physical activity. The reason why I chose 1.55 is, as a teacher, probably I assume that she will walk to school. When she's teaching, she'll be walking around the school or inside the classroom. It's a form of an activity. That is why I didn't use the minimum one. If it's a teacher who will just move in a car, go and sit in the classroom, move away from the classroom, be in her car and come back home, probably I will use the 1.40 because I'll be with the minimum one because she doesn't involve herself in any form of activity. So I want us to assume again that the woman is now agricultural worker who does non-mechanized farming. It means that she doesn't use any machine. She just uses her manpower or energy to perform the activity. So when you look at the factor, it is between 4.0 to 4.4. So let's use 4.2. It is 2.0 to 2.4. So let's use 2.2 as a factor to do the calculation. 2.2. So let's use 2.2 as a factor for the one who is an agricultural person. What did you get? What did you get?
Sir, please, I had 2,477.86 kilocalories.
Yes, so that is it. So anytime we want to, a question will be set here. You will be given the activity factor of the person. Yes, Rama 2.
Sir, I had 2,477.2.
Yes, that is, you are correct. So I am hoping that anyone who will multiply the 1,126 by 2.2, that should be the answer you should be getting. When you don't get it, then there's something wrong with your calculator. So that is what I can say. So anytime a question will be set, your activity factor will be given to you. You are not there to go and memorize these activity factors, and we will definitely give you activity factor. Then you base on it to do your calculation. Can I move on? Since we have wasted a lot of time here, so let me go ahead. So whatever that I said is what we have, the calculation has been done here. So when you read them, you understand. You understand? They are saying that pregnant women 200 kilocalories a day during the final 3 months of the pregnancy, and breastfeeding mothers have increased energy requirement, which is true. When you are pregnant and you are getting to the latter part, especially the 3rd trimester, your body may require more energy as compared to when you are not, because at that time a child has fully formed, and when a child has fully formed, the energy requirement of the child will become a burden to you, the mother. So you need to increase your amount of energy that you consume. You say that pregnant women may compensate for the extra demand by becoming less active and using the energy more effectively. So what the pregnant woman, what's most of the time it happens is, when people are pregnant, they are less active. They are not more active. So the energy probably that will be involved in physical activity, a lot of the physical activity may be involved in taking care of the child. But so when there's an insight whereby a pregnant woman also exercises, it means that you need to the 200 kilocalories should be added to your food that you've been taking, so that the child can get the required energy that the child is looking for. Okay. What you are also saying that extra requirement for breastfeeding mother depend on the amount of milk that they produce, the fat stores that have accumulated during the pregnancy and during the breastfeeding. So most of the time during pregnancy, when you are pregnant, your body tries to build a little bit of fat stores, and also for accumulation, in order that when you are breastfeeding, those ones, some of them can be used in the form of energy for the child. There's an assignment here. When you have time, you can do it. You say that use the BMR you calculated earlier to identify your physical activity level and calculate your estimated energy requirement. I think we've done that. And we said that why is it important to know one total daily energy expenditure? So you need to go and read on that and put it inside the platform. I'll look at them. Explain the reason why it is important for one to know your total energy expenditure. I don't think it's something that is difficult. So after working out on how many calories the body uses per day, one can then estimate the amount of energy you consume through your food and meal. So once we've been able to know this, we can calculate our food that we can control the amount of energy that we consume through food and drink. Because remember, when you are also taking drinks, contain some amount of sugar, and those sugar is a form of energy. What is the carbohydrate that the body takes? So when we are talking, we don't only think about the food. Most of the drinks that we've been taking, whether soups or the normal food drinks and stuff that we've been taking, we need to take note of all these things. I would say that the dietary reference intake, you remember we did this last week. That is the drill. We did the recommended daily allowance. We did, which again, the tolerable upper intake, upper limit. What again? We did a lot. We did different types. We are saying that makes recommendation for nutrient intake value that are likely to prevent nutrition-related problems. So if you remember, most of the thing that last week we did, we were saying that those values are there to help us to maintain our normal health. And most of them are also, especially the recommended daily allowance. We said that they were estimated for nearly about healthy people in a specific life cycle. So their aim is to make sure that we don't fall into any disease related states, or let's say diet related disease states. That is what I need to put it. And we said that the recommendations are based on what is your age, your gender, and specific group need to consume in order to maintain the required amount of energy for a particular lifestyle. We said that it is this recommendation, that is why we have, or people have developed a lot of guidelines, such as the 6 Ghanaian food groups. I think those of you that have been teaching BDT or food, you know this 6 Ghanaian food group. What is it? Can we mention them? The starchy root and plantain. What again?
Bodybuilding.
We have beans, nuts, and oily things.
Oh, those mentioned bodybuilding, and those are not the 6 food groups. We have proteins and animal. Yes.
So we have the group 1. We have the animal and animal protein food. Then we have the beans, nuts, and oily seeds. We have fruits and vegetables. We have the cereals and grains, starchy roots and plantain. Then we have the fats and oils.
Very good. So these are the 6 Ghanaian groups, food groups that we have been able to group our food into 6 main categories. That will help us to know that when we are consuming our food, we should inculcate these ones in order to get the actual nutrient that our body needs. If you go to China, they also have what we call the pakoda. The pakoda, that is also their food, the grouping system that they've also done. We also have my plate. Those of you who have been seeing these images, my food pyramid and the rest online. That is what the white people also use. That if you have a food, maybe 40% should come from whole grain, 30% should come from protein, and that is my food plate. They also have a pyramid. The pyramid gives you indication that those food at the down, you can consume them a lot. So the last one you should consume in minimum. And most of the time, when you look at my pyramid, the last food group is the one that contains a lot of fatty foods. Then they will limit your intake of that. So it is just a guideline so that you will not fall into a disease state. They will say that the amount of nutrient, the food is 3 energy yield nutrients are carbohydrate, protein, and fat and oil. They say that when food containing these nutrients are consumed, they undergo metabolism. That is breaking down and building of muscles. Now, when we talk of metabolism itself, metabolism is not just breaking down. We have breaking down and building up. So we have anabolism and catabolism. They all form part of metabolism. If you have free time, you can also read on that. And we said that the RDA, you remember the RDA, the recommended daily allowance or national recommendation for nutrients are compiled and published periodically based on prevailing observation and scientific evidence. But what we need to understand is these recommendations, it is not stagnant that they will do one and stop. Things are changing. Our body states are changing. So with time, periodically, they will do it and come out with a new one. So the old one may not be used at the moment. So as time goes on, a lot of research has been conducted and they are being improved upon them. Esme, is your hand up? Do you have any question? Or it is the old one?
Sorry, the old one.
All right. We are saying that this recommendation may either be quoted in grams or in percentage. It is relatively easy to divide the total daily requirement in grams to ascertain what should be consumed within 3 main meals of the day. So you see, let me take my time and say this. When we did the calculation, we had, let me use the last one for the example. We had 2,477. That is when we picked the BMI, which was 1,126, and we multiply it by the physical activity, which was 2.2. I'm talking about the second one that we did. They are the agricultural worker. So we have 2,477. That will be the energy I will need for the day in order to maintain my normal weight. So I will eat breakfast, I will eat lunch, I will eat supper. How will I get each contribution to this? Because I will eat 3 times a day. So what I will do is I will divide this particular figure by 3. Do it and give me the answer. Divide 2,477 by 3 and give me the answer. What did you get?
So 825.95.
So can we conclude that we had 826 kilocalories? Can we use that?
Yes, sir. When we round it up. Yes.
Yes, 826. So what it is telling you is that the breakfast you are consuming should contain 826 kilocalories of energy. The lunch you'll be taking should also contain 826. Then the supper you are going to take should also take 826. Please, do you understand what I'm explaining? Do you get it? Hello, are you with me?
Yes, sir.
All right. So now, if you want to do it, now that you have gotten the various daily, the various food pattern, that is breakfast, lunch, and that of supper. When you are cooking your food, in nutrition, we have what we call food models. So those of you that have been to the hospital, or you visited a dietitian unit before, we have what we call the food models that we use to estimate some food. Sometimes you go and see some banana models. You can see something that has been carved in the form of watermelon. We use watermelon. We have ladle that we use to measure rice and stuff. We call them food models. And these models, each of them is having their own grams. So we can say that when you fetch about 2 ladles of rice, you have gotten, let's say, 5 grams. So if you want to calculate the energy intake or energy value of that particular rice, we know that rice contains carbohydrates. So if it is 5 grams, 2 ladle give you 5 grams. You multiply the 5 by 4, then you get what you call, you get the 20 kilocalories. To tell you that the 2 ladle of rice that you have fetched is contained, or it contains 20 kilocalories. So that you can use it to do your calculation. Please, do you get that point? I know I'm rushing through, but you need to understand. Do you get the point I'm making?
No, please.
But do you get it up to where we've been able to get each of the food component within the day value? Have you gotten to that point?
Yes, sir.
Okay. So let me continue. Probably the slides may even talk about it, so you let's go. So we say that the recommendation quote in percentage, or in the other hand, require that the individual first of all calculate the amount of energy in absolute value and convert them to value of grams for easy use. So we can get it. One of the main reasons why I have not asked you, at a point you may think that once I've gotten 826, then why don't I divide it into 3, so that you are portion each of them to carbohydrate, fat, and protein. Has that thing okay in your mind now? Have you thought of it? Have you thought of it? Hello, have you just thought of it that?
No, sir, because each nutrient has its own number or the calories you are supposed to take.
All right.
So when you divide it direct by 3, it will not be.
You'll get it wrong. Okay, so we are going to do some calculation that will tell you how you are going to apportion each of the nutrient here. So we are going to do some. We are going to use some percentages. There's another recommended daily allowance that will give you percentages of the nutrient that you need to consume within the day. So let's go ahead. When we get there, we will do those calculations. So we said that, for instance, the RDA for carbohydrate for a male within 19 to 30 years of age with BMI of 22.5 may be stated at 130 grams. 130 grams, that is for the day. A recommended for fat for a healthy male and female adult could also be around 20 to 35%. The total daily energy requirement from food should be able to calculate the specific amount of calorie, that is 20 to 35% of fat an individual who should be taking. So generally, the total daily energy to be consumed by a healthy adult to maintain present weight is 2,000 kilocalories. That is, the energy from any of the 3 meal yielding nutrients should base on 2,000 calories. Unless otherwise indicated, since some people may require more or less, and we know that some people may require more or less calories based on their level of activity, they may require less or more. We also say that the following procedure may be followed to calculate the recommendation percentage. For instance, 20 to 35% energy from fat is calculated as below. Please, are you following? So let's use the first one. Let's use our 2477 as our total energy, or total, calorie that we need for the day. The book has given, the slides has given each one, but I want it to be more practical. That's why I'm using the calculation that we have done so that we can follow. So what it is telling you is that somebody who is a healthy person can also consume the fat intake should be 20 to 35% of the total calorie that you are taking. And your total calorie is 2,477. And if I want to calculate your fat content, I can take any figure from 20 to 35. If you think the person, for this person like this, who is a pure agricultural person, who is involved in a lot of activity, I can even take 35 because the person will still burn the energy and use it to perform activity. So let's go in for 35%. So what are you going to do? You are going to get 35. What was the total this thing? What was it? So we are going to get 35 over 100. Then I multiply it by 2,477. My people, I know I'm running faster, but here you have to follow in order to understand. Now I want to, with the total 2,477, that is the calorie you need for the day. Now I want to calculate your fat component of it. I will get 35. Well, that is the formula that I was given to. I said 20 to 35. I chose 35 because we said that the person is very active. The person performs a lot of physical activity. So even if the person take a lot of fat, it can still burn it. So I'm taking the 35 because of the level of activity. When I'm doing it for someone who is a sedentary worker, I will go in for 20 because the person doesn't do any activity. So consuming a lot of fat may increase your weight. Please, are you with me?
Yes, sir.
All right. So let's do the calculation. 35 is the percentage you have chosen. Then you divide it by the total percentage. And we know total percentage is always 100. Then you multiply it by 2,477, which is your total daily energy expenditure. So do it and give me your feedback.
So the answer is 867 kilocalories.
867 kilo.
67 kilocalories.
Okay, 867 kilocalories. All right. Any other person? Did you get the same thing?
Yes,
Yes,
sir.
please.
Okay, you had the same thing. Now we've gotten kilocalories. That is the total energy for what is it? Of fat. How are you going to convert it into grams? Who can tell me? How do you convert it to grams? How do you convert it to grams? Yes. Rejoice.
So maybe we divide it by 100.
You divide it by 100. Is it true? Yeah, I don't agree. Yes. How do you convert it to grams? How do you convert it to grams? Hey, Mabumo, Adewe Ayo. Okay. Esme, how do you convert it to grams? Esme.
So maybe by 10.
Sir, please, we know that this one, sir, this one is fat. The one we did is fat. So we know that fat is 9 kilocalories. When we are taking fat has 9. So what we do is we divide the number we have, that is 867 divided by the 9, and then we'll get the answer.
All right, that is it. We all know that 1 gram of fat is equal to 9 kilocalories. Is that not so? So if you have 867 kilocalories, you want to convert it to gram, you just have to just divide it. Because if it was gram that you want to convert to kilocalorie, you multiply. So this one, you divide it. So you divide the 867 by 9. And what will you get? What will you get?
Sir, please, you get 96 grams.
96 grams. Cynthia, what did you get?
So 96.3.
Okay, 96.3.
At
It's
96.
automatically 96. So you see how trickish the calculation is. We can ask you a lot of questions at this point. There's a lot that can be asked. That is why I want you to follow the steps for the calculation. Now we are done with fat. Let's move on. We are done with fat. I think these are the calculations that they also did. We are done with fat. So calculate for the carbohydrate and let me see. We are done with fat. Let me get the carbohydrate. What is it? Formula for you. Carbohydrate is always 45 to 60%. Okay. So carbohydrate is use 45 to 60% carbohydrate for the same person. And we know the person is physically active. So let's go for 60% carbohydrate. So calculate 60% of the 2477 and give me the max that you get. Let's go for 60%. What did you get?
So 1,486 kilocalories. 486.
1,486 kilocalories. Now, this is the carbohydrate value inside the total daily expenditure of the person in calories. Now we can convert it into grams. Because if you want to calculate it, if you want to do the estimation for the person, let's probably you put it into grams. So how do you convert carbohydrate into grams? You divide it by what? You divide it
by 4. By 4.
By 4. Good. Good. You are now following. You divide it by 4. And what did you get?
372 grams.
372 grams. So you see, then let me show you how you can also do protein. I think protein is also 10 to 30. Yes, this is protein. Now the protein, let me tell you, I will teach you two things here. There are two ways that we can calculate for proteins. There are two ways. We said that the RDA for protein adult is 0.8 grams per your body weight. Per your body weight. So if the question gives me your body weight, like you are, let's say the person body weight was 69, the one who gave us a body weight. If I want to estimate your protein intake, I have to just multiply your body weight, which was 69, by 0.8. I had 55.2. That is your body weight. So you can use your body weight as a way of estimating someone protein intake. Now let's use the percentage. The percentage protein give you 10 to 35%. So let's look at the person. This is an adult who involves herself in a lot of physical activity. So she just needs the protein to maintain the normal metabolic issues. So we can go in for either 20%. 20% might not be bad. So let's go in for 20%. So let's do the calculation. 20% of the total daily expenditure, and let's see. Do it and tell me the answer. Do it and tell me the answer.
So the answer is 495 kilocalories. 495 kilocalories.
Kilocalories. Please, are you all following? Rejoice.
Yes, sir, we are following.
Okay. So 495 kilocalories. Now convert it into grams. This one is in kilocalories. So convert it into grams. Convert it into grams. Any other person aside estimate, someone should also talk.
124
grams. So you see, there are so what will be okay? Don't let me go there. But let me ask this question: did you realize that when we use the body weight to do the calculation, I had 552. 55.2. But when we use the percentage, we had 1,124 grams. Have you realized that? Have you realized that? Hello.
Yes,
Please
sir.
wait.
Yes, sir.
Yes. I told you that with protein, you can use your body weight to do the calculation, and you can also go in for the percentages. But when you use the body weight, you realize that the body weight figure is low as compared to the percentages. So it is also telling you that it is not always that you can go in for the percentages when you are using protein, because you may exceed your requirement. It may be more than that, because as for the body weight, it gives you specific that if your weight is 20, you are supposed to consume this amount. But with the percentages, it's based on your discretion. You look at the person, nature, and everything, then you come out with the calculation. So that one is more of estimation. So that is what you need to understand when you come to that. So now we have been able to convert everything into grams. This is where you can portion the food. So the protein, the gram, you have 124 grams. And we said that when you measure one of our food models, when you use matches box, we said that matches box contain 4 grams of protein. When you are eating fish or meat, that is fish or meat, that is more of or let's say you are taking meat and you get a matches box size of meat. You said that it contains 4 grams of protein. So I'm just trying to let you know that there are various ways that you can. Someone has asked a question. Please, can you help with the body weight calculation? Yes. Someone should talk about it. I think I'm talking too much today. Someone should help her. How do you use your body weight to calculate your protein intake? Someone should help her from the class. Yeah, someone should help her. Obiankasa.
Okay, sir. I remember you said that the RDA for adults, when you are taking the protein, is 0.8 grams. So you take the RDA given, then you multiply it by the weight of the person. So when you use the RDA and you multiply it by the weight of the person, you get the protein.
The person who asked the question, are you okay now? So once you know your body weight, just multiply it by 0.8. Then you get your protein intake. All right, let me move on. Please, are you all okay up to where we have gotten to? Are you all okay up to where we have gotten to? So you see, with the calculation, the questions can be a lot. And most of the time, apply nutrition, the question comes in the case study form. You just analyze the case study, then you'll be doing the calculation. And after that, you'll be writing the reasons why those figures are important. So you need to understand that. I don't know. I believe everyone is on course. So let's continue. Yeah, Ramatu.
Yeah, thank you, sir. Sir, please, if I will, the question I asked about the body weight. So I will take 0.8 multiplied by the lady's weight she gave 69. I don't know whether that's what I'm.
Yes, 69, yes.
And I want to ask, when we are given a question and they want us to use this method, will you be giving the body weight?
Oh, automatically, you'll be giving the body weight. You will be giving, without the body weight, probably you can't calculate for it. So you'll be giving the body weight. We can even ask you, use the body weight measurement and use the percentage. And at the end of the day, we ask you to compare and state the reason why they're different. And you explain, you can tell us which, and we can ask you which one do you think is good for you to go for. Then you state your reasons. So it's supposed to be more practical. All right. Let me move on. Let me move on. I will say that calculating protein need or recommendation intake is, however, slightly different from carbohydrate and fats. If the recommendation is not in percentage, once the body weight is known, you just multiply the weight with 0.8 gram. If the SI unit or divided by weight by 2.2. So sometimes you can be giving the body weight in pounds. So when we give the body weight to you in pounds, you divide it by 2.2, then you get grams. That is what the point is trying to tell you. So let's look at the procedure. It says converts the pounds to kilogram if necessary. That means when it was given to you in pounds, then you convert it to kilogram, because body weights are supposed to be in kilogram. But sometimes, you know, when you pick the white people, most of the time they measure most of their body weight in pounds. And we say that multiply the kilogram that you have gotten by 0.8 to get your recommended daily grams per day. We say that older teens, 14 to 18 older, you multiply it by 0.85. Someone should tell me the reason why. Tell me the reason why between 14 to 18, their protein value that they gave per the body weight is 0.85 instead of 0.80 in an adult. Someone should tell me why. Tell me why.
So because the age range 14 to 18, they do a lot of exercise and therefore they use a lot of energy in doing that. So for them, they have to take in more energy so that it will compensate whatever they are doing.
If you think so, why didn't we allow them to rather increase their carbohydrate intake? Right, we are talking of protein. Can someone counter her argument? I want someone to counter her argument.
So I want to counter. Okay.
I think I saw patient have. Let me allow her to talk. Patient, talk. Oh, patient, I've given you platform and you don't mind me. Let me come in. Patient don't want to talk, so you can come in.
Sir, please, what I want to say is within that age range, they need to develop most of their body parts and then the organs and other things. And then because they are into more activities too, they have to repair worn out tissues. And then we know that that is the purpose of protein. That is why they need more protein than that the adults, so that they can
Think
use the
that
protein to
the
develop.
teenagers needed more. Sir, I'm talking. Is the network?
Okay, talk. I'm listening.
Hello.
I'm listening.
Sir.
I'm listening. Talk. All right, let me proceed. I think I agree with what Esme said. One thing you people should know is adolescent is the age of rapid growth. If you don't grow well during adolescence stage, you become old, or you get to adult stage, the growth becomes slow. When you are after 18 years, you are not able to become tall. Forget. You just manage your situation like that. If you are not able to grow well during the adolescent stage, when you get to adult stage, it slows down. Growth automatically slows down. That is why their protein intake should be increased. That is why their protein intake should be increased. So let's note that. So if you look at the example that has been given in the slide, you see that the body weight was given in pounds, which was 150, and it was divided by 2.2, and they had 69. 68. So even our own that we used was 69. So the 68, when they multiply it by 0.8, they had 54. Our own was 69, so I had 55.2. So you see, there are no other. They are not all that different. So we need to just understand that. Then we are saying that calculate the protein intake for students whose weight is 65 and she has a low protein intake of 9%. And high energy intake of 2,500 kilocalories a day. We are doing this work. What I want you to do is and give me the answer now. So read the question. The A says calculate the protein intake of a student whose weight is 65 grams and has low intake of protein as 9% of energy and high energy intake of 2,500. So the daily energy is what? 2,500. how does his protein intake compare to daily value of 50 to 175 grams? Then how does this protein intake compare to 10 to 35% recommendation? So I'm waiting for your answers. Do you understand the question? Do you understand the
No,
question?
please.
Which part of the question that you don't understand?
No, sir.
Which part of the question that you don't understand? You say you don't
Sir.
understand the question. Yes.
Sir, please, I have, when you asked the question, I was talking, but the network wasn't
I
allowing
didn't
me.
hear. I didn't hear anything. So if someone
Yes,
answered
it
it, so
was
if
the network.
no problem.
Yes, so
Yes,
sorry. Then
you
please,
people
I
are saying.
wanted to ask that the range given, sir,
I'm
the
listening.
range
Talk.
that has been given, 50 to 175 grams, and then the range of the percentage to, are we to choose anyone, to choose any value of your choice, or
The B portion. The B portion you
the
are
B
not
and then the
doing.
C?
The B said how does the protein intake compare to daily value of 50 to 75? So the B and the B value you are not doing calculation. It is the A and the C that you do calculations. I think the B value I have not thought about it. So you just leave the B alone. Calculate the A and that of the C. And let me see. So with the C, let's all agree to use 20%. With the C, let's all agree to use 20%. Are you done? Hello? Hey, Obiangaza. Asemamba. Asemo. Asmin.
Sir,
Where is Wula?
sir, her phone, oh, she's having phone issues. So she can't join like that. Her phone
Hey,
is spoiled.
we are doing calculations, so she can't even borrow somebody's phone for just class and give it to the person back. Hey, Muriel. Hey, Francisca, tell me what you have gotten.
I got 56 grams of protein.
56 grams of protein. How did you arrive at that? Can you just take us through? Francisca, take us through. I want to understand how you were able to get that value.
Please, sir, they've given us the total energy intake to be 9% for protein. Now, the total energy intake for oil is 2,500 kilocalories a day. That includes everything. So you are going to take the 9% of the 2,500 kilocalories so that you can get the kilocalories for protein, which I did. 0.09 times 2,500 and I got 225 kilocalories. Then I proceed to take 1 gram of protein is equals to 4 kilocalories. So to get the gram, I have to divide that by 4. So I divided 225 by 4 and I got 56.25 and around it to 56.
Do you agree with her? Hello, class. Do you agree with her way of doing the calculation? Hello? Hey, move me.
Sir, feel.
I want to listen to other people before I make my comments. Okay, Francisca, thank you. Let me listen to other views so that I will know how to handle the situation.
Okay.
Any other person? As Alima too.
Sarah, please, I don't get it. I need more explanation on that. Thank you.
You don't get what? What have you done that you don't get it?
The explanation she gave, it's like I'm
And
confused.
so, yes, don't get confused. Tell me what you also did. Alima, tell me what you did.
Sir, what I did was, okay. Sir, you said that to get the weight, we multiply it by the 0.8, so that we'll get the weight. So I took it from there. Hello?
I'm listening, talk.
So after I multiplied it, I have 52 grams. Then I multiply it by, we know that for protein, it has 4 calories. So I multiplied by 4 and I had 208 calories.
Are you done?
Mm.
So you had 208 calories. Okay. Let me continue. Any other? Who again?
Sir,
That's me.
sir, please. I had 188.8 kilocalories.
188 kilocalories. Tell us
Yes,
how you
sir.
did that.
So you said 65 grams. We are using the 9%. So I did 9 divided by 100 times the 65, and I had 58.5 grams. So when I round it up, I have 59 grams. So 59 grams times the 0.8, I had 47.2. And then I multiplied it by the number of protein calories. That is the 4. That is the 47.2 grams times the 4. And I had 188.8. And then with the percentage, I did 188.8 divided by 2,500 times the 100. And I had 7.55%. I don't know whether it's correct.
Oh, me, I'm just listening. I want to just get most of the views so that I will know. All those who have stock, there is an issue with everything that we have to still tackle it. I want to hear more views. There are a lot of people online and they are not talking. I don't know. Nyam, Deborah, Dorcas. Where is Dorcas? Doki?
But I'm confused.
You are
please.
confused.
Yes,
Yes,
please.
tell us what you have gotten.
Sir, Dorcas is using a new nyamo.
Sir, please.
Doki, you are telling me something.
Afajato.
Yeah, try and find yourself. Oh, if not, an animal will just chew you up in the forest. Juliet, Ohene, today you are not talking. And Letitia. Hey, Zulea, where are you? Today we are doing mathematics. You are lost. I can't hear your voice again. Mavis, a champon. Mavis, tell me what you had. Hello. I'm taking my people back to classroom. All right, so let me come in. I think you all try, but the question trick you a bit. Yes. Who want to talk?
Sir, won't Juliet because Mr. Myra, that's an American and I'm a yard before front to me focus. Tama, me bow on track on that. Said, baby, I'm in a maintain.
You were doing something different.
I
Me, I won't go back. We are all in class now. You just went and do. Is it why online class is painful? Look at the way I'm sweating. I finished 1 bottle of water just this morning. I'm done. And you are doing something different. Okay, no problem.
it's
Let me
the kids
continue.
there. Well, if I don't fix them, they won't be.
Run away from the house. You are in school.
Okay, sir.
All right. So let me come in. You see where Esme and the other lady, you people have problem with the 9% over there. The 9% just confuse you. The question says calculate the protein intake for a student who weighs is 65 grams and has a low protein intake. So the person protein intake is very low, very, very low. Because it is low because when you finish the calculation, you even get to know that it is getting to 9%. And it gives you the total energy or high calorie as 2,500, which is very, very high because we all know that mostly the normal healthy person is supposed to be around 2,000. And the question says, how does his protein intake compare to daily value? So there is also another recommendation that says your protein intake should be around 50 to 175 grams. That is the daily values. 50 to 175 grams. So when you finish and you calculate and you see that you are within that, then the person has met the daily value. That is another point. And the last point says that how does his protein intake compare to 10 to 75%. Is the person within the range or the person is not within the range? So this is how I want you to tackle the question. First of all, the body weight of the person has been given to you. And we know that with a normal person, adults, once they didn't tell us the person's age, we assume the person is an adult. But they said that the person is a student. A student can be an adult student. So we assume that once the age is not given, you go in for an adult. An adult, we said that everybody, 1 kilogram of body weight is equal to 0.8 gram of protein. So if it is 65, then you multiply 65 by 0.8. What did you get? Tell me. When you multiply
52 grams.
52
grams.
Yes, 52 grams. Now we've gotten 52 grams of protein. It is in grams. And once we are trying to compare it to that of our calories, then possibly we need to convert it into calories. So convert 52 to calories. What will you get?
208 kilocalories.
208
kilocalories.
208 kcal. Okay. So you are done with your calculation. Now the question is coming to ask you. They went further to ask. Now let's solve the B. The B says that how does his protein intake compare to daily value of 50 to 175 grams? What will you say? What will you say? What will you say?
So I don't understand that question.
You should understand. The question says.
So is what?
The question says. Okay, let me put it this way. There's another school of thought that says that your daily protein intake should be within 50 to 175 grams within a day. Now you have calculated your protein intake and you have 52 in grams. Here we are talking in grams. You have gotten 52 grams. So the question asks you, compare what you had to 50 to 175 grams. Is the person meeting his daily intake or exceeding or below?
So the person is exceeding.
The person is within the range.
Esme said exceeding. Someone said within. Yes, Rejoice.
The person is within the range, but closer to the lower range.
Okay, within the range. Francisca.
The person is within, but on the lower side.
Yes, Zuleha. Zuleha, where is she? People will come online and you'll be sleeping. Loretta, where is Loretta? Enin.
Please, I'm not sleeping. It's within, but almost
okay.
like.
This is my first time hearing your voice today. I thought maybe you were sleeping. Esme, do you agree with them now? Esme.
I say yes, 52. 52, yes.
So 52, you are within the range. How do you understand? 52, you are within the range. So we have been able to solve the A and the B. Now let's go to the C. This is where I don't know. Did somebody got the C right? The C. The C. You want to calculate for the percentage, the C. How do you calculate for the C? Someone should help me. You have to calculate for the percentage before you can do the comparison. Yes, Rejoice.
Hello, sir.
Yeah, Rejoice.
We will take the 208 that we have gotten, divided by the total kilocalories, which is 2,500. So when we have gotten the answer, we multiply by 100.
So when you did that, what did you get?
So the answer is 8.32%.
Okay, so the whole class, do you understand how she was able to do her calculation? Is someone also having different methods so that we can look at it? And are you following?
Yes, sir.
Okay. Ask me.
So please, the 9% there, what was it doing there?
It is giving you an indication that the person protein intake is very low. So even when you did the calculation, have you also realized that you had 8 point what? 32%.
Okay.
Yes. See, getting closer to 9.
Okay, sir.
It's telling you that the person protein intake is very low. And the question C,
Okay.
the question C say,
Sir,
how does yes.
sir,
Hello.
sir,
Patient with you.
sir.
Patient, I'm
Hey,
listening. Ah, some more. You wanna hear man? Can we go on? See, the problem is if your network is not good, I cannot help you with issue of network. When you say you don't understand, now is within my limits. And the way we are doing today's lesson, if you don't follow it from the beginning to the end with a stable network, you will get lost along the way. That one, they have to be sincere. See, my time is almost up, so I have to quickly. So what's the point C? What the point C is telling you that how does his protein intake compare to 10 to 35% recommendation? So what you need to do is his protein intake is 8.3%, which is below 10 to 35% recommendation. So here, the question can further ask you, what will be your advice as a nutrition person? And you say that the person should probably improve on his protein intake, or you advise that the protein intake should be moved from that of the 8 point whatever to that of probably either 15 or something. That should be an advice, because when you look at a person total daily calorie is very high. 2,500 for a normal person is very, very, very high. So if protein alone is only 10% or 8 point something percent of it, it is not the best. The person is not taking the right requirement that the person is supposed to take. All right. So let me try and finish what I'm supposed to teach. I think the solutions are even here, so we can just look at them later on. Then there's another question here. We are almost done. The rest are just questions. A diet of a woman who is 26 years old and weigh 165 pounds, provided 1,500 kilocalories a day with 50 grams carbohydrate and 100 grams of fat. What is the woman protein intake? You need to do the calculation. If her protein intake is her protein intake appropriate, justify your answer. Are her carbohydrate intake appropriate, justify your answer. Start work. And this one, all the justification, you will tell me about it. Start work. I'm giving you 4 minutes. My water has finished. Let me go and get another one. Start work. I am back. Who is Dan? Who is Dan? Yes, Memune to Sani. Memune to.
Hello, say.
Yes.
Hello, say.
Yes.
Say, please, you mentioned my name.
What is your answer? Tell me.
Say, we were given the woman's carbohydrate, which is 50 grams.
Mm-hmm.
The woman's carbohydrate, which is 50 grams, you multiply it by 4 kilocalories. That will give you 200 kilocalories from carbohydrate, because we already know that carbohydrate is 4. So you multiply it with the 50 grams that they gave it to us. Then you take the fats. We know that the fat is 9, and they have given us 100 grams. So you take 100 grams of fat, then you multiply it with the 9 kilocalories, which will give you the 900 kilocalories from fats. Then you come and take the the weight, 165, which pound provided with 1,500 kilocalories. Then when you bring that one, you bring brackets. Then you bring the 200 that you get from the carbohydrates, plus the 900 you get from the fats. Then bracket close, which will give you.
Are you reading my solution on the slides for me, or you are doing your own calculations?
So I'm doing my calculation here.
Are you sure?
Yes, sir.
Because your calculation you are doing.
You said we should do substitution.
Who said it?
Said from the initial what you gave it to us when we were working about the woman. What is that?
But that is totally different from what you are doing now.
Yes, sir. But sir, we were giving so we're giving the 50 grams for the carbohydrate. Then I multiply it with the 4.
The whole thing is I understand where you are coming from. But what I'm saying is the way the answers has been solved in the slide, that is exactly you are reading. That is why I'm asking you, because I know the answers are there, but I intentionally give it to you because I want you to practice it, so that you really understand whatever we are doing. Even last week I didn't check the solutions are in the books, like the slides. Like I won't forward them to you. That is why I mostly teach afterwards, and I give you the slide. All the same, that is good. I think you have the first one. I wanted you to answer the first one. So tell me, justify what is the human protein intake? You have shown your calculation. So the B says that is her protein intake appropriate? Tell me, is the protein intake appropriate?
So with the woman's protein.
Is her protein intake appropriate? Why no?
So it's above what they gave. When you multiply it, it's above, because when you calculate it, instead of they gave us 50 grams, they gave us protein weight. So they gave us 100, and now the woman, when you get about 59 or 60.
Who gave you 100?
So so with the carbohydrate is 50, and then the fat is.
I'm asking you of protein. Which one is 100?
Say, so let me write Mama Trouble. Say, listen. So you say that the carbohydrate, you say it's 50. Then I say we will multiply it by 4. Then you say that with the
I'm coming. Take your time.
Okay.
Take your time. We are working with the question. The question says the woman, a diet of a woman who is 26 years old, who weighs 165 pounds, provide 1,500 kilocalories a day with 50 grams of carbohydrate and 100 grams of fat. So you can clearly see that the only nutrient that was not mentioned here was protein. So automatically we are going to calculate for protein. And you said you have done your calculation for protein. And I'm asking you, is the protein intake appropriate? Because one, there are 3 ways that we can identify whether somebody's protein intake is appropriate. One, we can compare it to per the body weight. 2, we can do it based on the percentage value that was given, which was 10 to 35%. And 3, we can compare it to the daily value, which gave us 50 to 75 grams. These are the 3 ways in which we can do it. So the question has asked you. So when you look at the question, there's one particular one that we cannot use it here. You can't use the 50 grams per, to 75 grams because the question, it doesn't have anything to do here. But once the question gave you the body size or your weight, it means that we can do the 0.8 and do the comparison.
Yes, sir.
And once the various carbohydrate component has been given, we can easily get the protein and check for the percentage and see whether they fall within the range or not. So that is what I will entreat you to do for now. Mamuna to sign it. Yes, let's go to Mavis. Mavis Akoli.
I'm lost though. From the first question, my network went off, so I was not able to hear.
Mavis, the time class 11 o'clock, you are supposed to finish at 11. So you see, it's not my fault. I think I've tried. And I mean, try. Are you the one who called me the last week and I couldn't pick your call?
Yes, sir.
Don't worry, we can find a way. Then I'll find a way to help you. Yeah, Rejoice. Let me hear from you.
Okay, so when I calculated for the protein intake, which is 400 kilocalories, I took the 400 kilocalories divided by 1,500 times 100, and I've realized 26.6%. So for us, 0.6%, approximately 27%. So to justify this, is her protein intake appropriate? The protein intake is appropriate because it falls within the 10 to 35% recommendation of protein.
Okay.
Thank you.
Did someone also use the body weight as a measurement?
Sir.
Yes.
Yeah, when I use the body weight, they've given us the body weight in pounds. So I divided it by 2.2, as you said, and I got 75 kg, which I multiplied by 0.8, which I got 60 grams needed.
60 grams, eh?
60 grams.
Okay.
So when I got 60 grams and she's taking 100 grams, it's like the 100 grams is more. So when I use that is what I got. So her protein intake is higher than recommended with using the body size. Thank you.
Welcome. Any other person? Anyonyam, where are you? Tell me something. Anyonyam.
Sir.
Yes.
I also use the body weight. Just as Francisca said. So when I got the 60 grams, then to get the amount of kilocalories for the protein, I multiplied by the 60 this thing by the 4. to get the 240 kilocalories.
Right.
Then when I finished, I divided it by the 1,500 calories they give times the 100. So for the percentage for the protein, I had 16%.
16%.
Yes.
Okay.
And so I
Are you done?
used, yes. So I
Are
used
you
the
done?
same thing for the carbohydrates with the 50 grams for the carbohydrates.
Okay.
Uh-huh. And I also had that. But for the fat, I used the 100 grams divided by the 1,500 times the 100. And I had
100 grams. Why
for
why
the
will you
fat.
why will you be
Hey,
dividing 100 grams by
no,
1,500?
yes, it's supposed to be kilocalories. Sorry,
So did you convert 100 grams to kilocalories?
sir, I've not done that one. That
So
was
it
the
will be
mistake.
totally wrong.
So
Yes.
100 times 4. So I have to do 400 kilocalories divided by the 1,005 times 100. So sir, that
Okay.
one, yeah, 400 divided by 1,005 times the 100. So I had 26.66. That is 27
20%.
percent. Yes, that is what I got using the body weight.
So what will you say if you get 27%? What will be your justification?
So, so for me, that is my problem. The justification is my problem. I wanted to ask a question. So, do you have to look at the range they have given you?
Stop.
Because I've not seen any range here for me to do the comparison.
No, the range,
In
they
the
will not give
question,
it to you. We will not give it to you. Most of the time, they won't give it to you in the question. But you are supposed to know. I have given you the range for carbohydrate was 45 to 60, right?
oh,
Fat
okay,
is
sir.
10 to 35.
45 to
If I,
60 couple.
fat is it 10 to
10,
35, if I'm not
10
lying.
to 35. Okay.
Yes, fat is
I
10
said
to protein is 10 to 35,
10 to
right?
35. Okay.
Then
Okay,
let me
so
check.
sir, looking at the percentage for protein, for the protein, what I had, I can say that is within the range, so it's okay. And then the sir, please, the carbohydrates. The carbohydrates, I will say it is low.
Why?
So looking at the carbohydrates,
Uh, why
540
is it
divided
low?
by 1,005. So 540 divided by 1,500. Yes. So I will say it's low because the range is supposed to be between 45 to 60. But this one, it is 36%. So
Okay.
it is lower than the range is supposed to be. But when you take the fat, the fat is between 10 to 37.
You said,
And
babe, I'm coming. What percentage did you get for the carbohydrates?
so the carbohydrates, I had 36%.
How did you get the 36? Tell me.
So the carbohydrates, I did how do you call it? That one too is 60 times. So no, it's not like that. I
You are
used
wrong,
fat.
right?
Yes, I've seen the problem.
Yeah, I didn't get it. So go back and come
Yes,
again.
sir.
Next patient.
Okay, sir. But sir, the fat is correct. The fat is 27, so it's within the range.
Okay.
Okay, sir.
We'll go back and come again. Yes.
For the carbohydrates, okay,
Yes.
sir.
Yes. Patience. Patience. You patient. I don't know where you are. Yeah, your network issues. It will be difficult for me to help you because when you talk, we hardly hear you. And anytime your hand is up, I called you and I don't hear anything from you. So I have been telling you that if you think you have network issue at your end, it is better you locate or you relocate and find yourself where you can get a proper network so that you'll be able to follow what you are doing. If not, I think I have exhausted my time. I'm supposed to close at 11 o'clock. So any other person with another issue? Any other person? Any other person?
And the patience, I can't help you out. Your network. When you are talking, we can't hear. And we can't hear you. You have to relocate your network. Your network cannot help you. So I don't know how to answer. I don't know your problem. Yeah, my joke.
Hello, sir.
Yes.
Sir, the carbohydrates. Yeah, so. So the carbohydrates is 13.
Are you there?
Yes, they are supposed to be 13.
Yes, 13. So that
Malome
one
daddy
too
lo
is
yo
very,
kono
very
kono
low.
akomo daddy be no kono.
Hey, patient. So are you sure you are in school?
So that one is very, very low.
Any other person? It seems Esme is the only one talking. I want to hear from the other
No,
members.
sir, I'm not the only one.
No, other people are here. I'm not hearing from them. Oh, I should close. Tilly, you are laughing. On your microphone and speak. Yes, Tilly. You are just there writing. Talk. Where is Tilly?
Akula zima ko daddy joking na.
The patient in the no more microphone. Yes, Tilly.
Yes, sir.
What did you get? Tell me.
In fact, I'm lost. I'm lost with this one. I didn't do it, please.
Zulaya, what did you get? Zulaya, what did you get? Vivian, I think I saw your hand somewhere and I forgot to call you. Vivian, don't call. Yes, Vivian.
Sir, I got lost too. I used this thing, the 0.8 in the calculation, and I had 60 grams. But from there, no, my answer was wrong. I got 16%, and I'm confused. So I'm still.
You have 60 grams.
Yes, sir.
For the protein, right?
I used the pounds. Yes.
You didn't convert it to kilogram.
I converted it to kilogram, and I had 75 kg. And then I multiplied the 75 by 0.8, and I had 60 grams.
I don't understand. You are confusing me more.
165 was the pound.
When you converted it, you had 75
kg.
Yes, so you multiply it by 0.8.
0.8.
And you had what?
60 grams, sir.
60 grams of protein.
Yes, sir.
And if you want to find out whether your protein intake is correct, what will you do?
That's where I'm stuck.
So you can convert the 60 grams into percentages. How do you convert into calories? How do you convert 60 grams of protein to calories?
Then I have to go by the 449 where protein is 4.
So they're getting the factors for what you will do.
I multiplied the 60 by 4.
And what did you get?
I had 240 kcal.
240 kcal. Then find percentage of the 240, what will you do if you want to find the
And
percentage?
I had 16%. That's where I don't know if it's my calculator again. I'm confused here.
Do it again. It might not be your calculator.
It's okay.
Yes, Francisca. Francisca. Francisca, your hand is having, you're not talking. Okay, let me conclude on this. It seems a lot of people, yes.
Sir, please, I had 60. So is it right now? 60%.
60% of
240 divided by the protein, the percentage of protein. 240 divided by 1,500 times 100. I was the one I had 60, and you said I should calculate it again. And the second time I had 60%.
So you see, it will automatically be wrong because the total even energy is 1,500. So the protein alone cannot even exceed 1,500. How we are written? Because the protein, you see, the protein alone cannot be. What you need to do is when you want to calculate for the protein here, it is obvious that when you subtract the fats, the carbohydrates, and the rest will be protein. You don't even have to worry yourself much. I hope you understand.
Yes, sir.
When you have 50 grams of carbohydrate, when you convert 50 grams of carbohydrate to calories, you get around, that is 50 times 4. What will you get? 50 times 4, what will you get?
200.
So when you are able to subtract each of them from it, you'll be able to know that this is the amount of what is left for my what is it? Let me put it. Yes, let me put it this way. Looking at a lot of people are confused. True or false? Especially
Yes,
when
sir,
we go to this.
Sir, please, true. Me, myself, I'm confused.
See,
He said true.
I thought you have left. You are sorry you are there.
Sir, this class, you have to reschedule it, please.
Sir, please, it's true. We should reschedule it, sir.
How much is all? How much is all?
So I'm not going to. Just I'm confused.
Sir, we are just confused.
All right. Let me see.
We are confused.
Let me see. In the course of the week, you were there. You didn't mind me. Now that you are confused, you are talking. So let me see. These things are not difficult.
Myself, I'm so confused. That's why I'm quiet.
I am in class. Keep quiet. I'm in class. I have come and I have taught. You people have understood. So don't worry me. Some of you are not following, and most of you to your network issues. Your network issues have been your problem. You go and come back. We are doing calculation, and we are basing on the previous thing that we have done to just do the next one. So if you don't follow it keenly, you will not be able to understand. But I'll try and have another 1 hour class with you in the course of the week. But I'll communicate it to the platform that we find ourselves. When I will be available, then we will meet. When we meet, we will just start from here.
Yes, sir.
Thank you, sir.
God bless you.
Yeah. Oh. All right. So let's call it a day. Before some of you just chew me on this platform. Bye.
Thank you very much.
I want to ask you for a question. When I ask for a question, today when I ask for a question, we will not close. So bye.
Say bye-bye.
Please, have you closed?